to welcome you here at our conference, Computational Linguistics in Bulgaria. This is our 6th edition. The conference was launched in 2014, and it is constantly growing on. So this year, we have the higher number of submissions. And also, it was reflected in the highest number of accepted papers for publication and for oral and poster presentations. Our authors come from many different countries. We have authors from Bulgaria, from Albania, Austria, Canada, Croatia, Finland, France, Italy, Japan, the Netherlands, Romania, Russia, Serbia, Spain, Sweden, the United Kingdom, and the United States. The main aim of our conference is to gather together Bulgarians who work abroad and here in Bulgaria in the field of computational linguistics, but also our focus is on researchers all over the world working in the field of natural language processing and in artificial intelligence-related technologies. Our main sponsor is the National Science Fund in Bulgaria, but also the conference was sponsored by the European Language Resources Association. We have the promise by Mr. Khalid Shukri to give some greetings, but unfortunately he is not online yet. If he managed to be here later on, I'll give him the floor. Also, our conference is sponsored by Lerai Foundation here in Bulgaria, and our media partner is Softuni. The conference was endorsed by Gate Institute at Sofia University and the company Adata Pro. So it's my pleasure to give the floor to Professor Silvia Ilieva, who is the director of the Gate Institute.
Thank you. Good morning, everyone. On behalf of Gate Institute, it's my great pleasure to extend our warmest greetings and express our strong support to the 6th International Conference on Computational Linguistics in Bulgaria. So we are truly honored to be part of this prestigious event, which serves as a vital platform for advanced research and innovation in the computational linguistics in Bulgaria. Also, I would like to take this opportunity to extend our gratitude to the organizers of the conference, especially the Department of Computational Linguistics and Bulgarian Institute of Bulgarian Language Institute in Bulgarian Academy of Sciences, and especially Professor Koeva for organizing this great event, bringing such researchers, Bulgarians and foreigners from abroad to share ideas and to be part of this event. So this conference, which is 6th in a row, established this as a cornerstone for fostering the NLP community, particularly those who are focused on small and less resourced languages like Bulgarian. And in this era of digital communication, it's essential that we ensure that we have equal access to languages and technologies, to all languages, regardless if they're small resource available. So at the Gate Institute, we are not only proud endorsers of this event, but also we are active contributors in this field. So we're having a strong team of researchers working in NLP and working on different projects and innovations to apply those research in different areas, application areas. We're working on smart city, intelligent government, and digital health. And especially in intelligent government field, we're working on combating disinformation and ensuring this healthy informational environment in Bulgaria and at governmental level. Also, for instance, LLMs have shown promising results in analyzing health-related social media data, electronic health records, and other health data, which is also our future work. So by sharing these high-quality scientific results, this conference not only strengthened the local research community, but also position Bulgaria as a key player in the international computational linguistic landscape. So this collaborative spirit which fostered here is critical to exchange ideas and to development of new methodologies which the researcher can further use. So in conclusion, I would like to wish a successful and inspiring conference, and may this CLIP conference become a platform for collaboration and for continual growth of our community. And let's use this opportunity to exchange ideas, to sharing experience, and to inspire for new excellent research results. So enjoy your conference in next days. Thank you.
I'd like to thank Sylvia, and now to give the floor to Mr. Ilya Krstev, the Executive Director of Data Pro.
Okay. Good morning and welcome. It's an honor for me to support the event for a third consecutive year, I think, if I'm not mistaken. I'll be very brief. So basically, in a world where large language models have become like more and more like a marketing stunt, it's more and more about research, it's about data, it's about science. And sometimes we are missing all that. So my hope is that events like that are also focused on small languages that have to, catch up with the bigger models and so on, is really of use. And on top of the research topics, we can do things around how actually universities, scientists, and companies work together. Bulgaria is becoming a more and more vibrant place when it comes to not only research, but also companies that are working with such technologies. So we are seeing more and more implementations in the last several years. And I really want to wish you to an event full of success, and hopefully we'll see a lot more in the real world of what we are doing here. Thank you very much.
Thank you, Ilya. And now I would like to thank our host institution. This is the representation of the European Commission here in Sofia, in Bulgaria. And I would like to give the floor to Mrs. Svilena Georgieva on behalf of the Bulgarian Department of the Directorate General for Translation at the European Commission.
Hello and welcome. It is my pleasure to greet you here in our premises in the House of Europe, where the European Commission is sharing with the European Parliament. I hope we're going to fix the air conditioning issue in some moments. Please bear with us. there are always some technical problems. If it's not the air conditioning, then it's the sound or something else. So please bear with us. But this said, I would really want to emphasize that for us, it's very important, your work, because the Directorate General for Translation, which we call DGT, does not make a difference between a big language and a small language. Romanian is as important as Estonian or as Bulgarian. We do have our own artificial intelligence. We do have a team that works with LLMs, with large language models, because we are actively using machine translation in our daily work. That's why we are practitioners. We are the users of what you as researchers are trying to find out and to work out in your daily work. That's why I would like to wish you a very, very fruitful conference, very fruitful exchanges, because I see that it's an international community here. It's called Computational Linguistics in Bulgaria, but still, this is an international event. So yes, please exchange, enrich your ideas and keep on your good work, because people like us need people like you in order to function well. So have a very, very good conference, and we hope to see you again.
Okay. Thanks, Elena. And now I officially declare the conference open. And I have the pleasure to introduce our first invited speaker. This is Dr. Veselin Stoyanov from TOME AI at GUSA. And I'm going briefly to present him. He is currently the head of AI at TOME, which develops practical applications for LLMs. Previously, he worked at the Facebook AI, where he led the development for standard LLM methods such as Roberta and Muti. Array and their application to improve online experiences, for example, reducing the hate speech and bullying posts. He holds a PhD from Cornell University and a postdoctoral degree from Johns Hopkins University. Veselin, the floor is yours.
I'm sharing screen from Zoom. Thank you, everyone. It's great to be here. And first, I want to thank Svetla and the organizing committee for inviting me here. It's really exciting for me to be back in the city I was born and grew up in, Sofia, and talk about professional stuff. And I really enjoyed this event, meeting all the people in computational linguistics in Bulgaria. So about me, thank you for the introduction, Svetla. Just to add a little bit more color. So currently I'm at the startup called TOME AI. I'll tell you about it in a second. I work on real-world applications of large language models. I'm also currently an adjunct professor in the Mohammed bin Zayed University of AI in the United Arab Emirates, where we have a lot of exciting projects on large language models, collaborating with an AI company there called G42, and also another company in the USA, Cerebras, that is building hardware for large language models. And prior to TOME, I spent almost 10 years at Facebook. I started on the search NLP team. Then I worked on machine translation, cross-lingual representation, pre-trained models, large language models. And as I was doing that, it was really exciting time in large language models. I was really in awe of the power of these models, and I really wanted to see them being used in the real world for tasks that they can bring value. So that's why I joined TOME. Yeah, I'm very passionate about solving real world problems through AI. And yeah, I think we have these models, but we still quite haven't figured out how to use them effectively and make them really drivers of economical value. So about TOME, we started as a new AI native presentation format, sort of a replacement for PowerPoint, but we've changed directions a bit, and we're now building an AI assistant for sales. Mostly this change was driven by the fact of us realizing that large language models are actually much better at extracting and synthesizing data than actually generating stuff that is creative, because we still don't know how to use that for everyday work applications. Yeah, so we are building this assistant who is your second brain. Trained to do the task and help this one particular persona in sales well. And we already can see that when we focus and target a single persona, we can do much better than the generic things that are out there. Well, today I want to talk to you about work that was mostly done at Facebook. It's about large language models for the real world. It had three parts originally. First, I'll talk a little bit about computational challenges with large language models and how we can use sparse LLMs to address those. I wanted to talk a bit about alignment and instruction fine-tuning, but I decided in the interest of time to skip that part. It's also a bit out of date today. And then challenges handling multiple languages, so cross-lingual models. So let's start with the first part. How do we tackle the computational challenges, and can we build more efficient large language models using sparse models and mixture of experts? Why do we want to train sparse models? Well, so as we were getting into neural models, we learned a few things that were sort of counter to what we knew about machine learning. First, big models are more sample efficient. So if you have less training data, actually, you learn better with a larger model. Very counterintuitive to how we grew up in ML. Big models are actually more compute efficient in some cases. So we have these curves of what's the optimal model for each amount of computation that you may have. And sometimes a larger model is more computationally efficient. And we also know that there are some capabilities that only show up in larger models. So for example, few-shot and zero-shot learning only happens in larger language models. So if we train sparser models, they allow us to get the benefits of a larger model with higher parameter counts while using less computation. So at the time, and this work is now a couple of years old, so a lot has happened in a couple of years. At the time, this was the most comprehensive study of sparse models for zero and few-shot learning tasks. And we showed that a mixture of experts or sparse models can result in significant computational savings, even at very large scales. We showed some differences, however, how dense and sparse models scale. And we trained a 1.1 trillion parameter model, which at the time was the larger model, and which still is pretty large scale, even for today's standards. So I won't go into details of what mixture of experts are. The idea is essentially that we have some feed-forward layers in the network that are active. So we have multiple versions of a feed-forward layer, and only one of them would be active for a given token. In the interest of time, I'll skip all the details, but just want to say that we'll be following a pretty standard sparse mixture of experts setup. And we'll compare them to a model that's dense, in which we only have a single version of the feed-forward layer, and all the parameters are active. So as it was done at the time, it will be alternating dense and expert and mixture of expert layers. We use top 2 expert selection, and we would use 512 experts in each expert layer. So we for these experiments, we followed what was the most successful models at the time, which was GPT-3. This was back at the time where they did publish the details of that model, so we knew how many layers and parameters each model had, and we tried to essentially match their setups with our dense models. And then we had our sparse models, which were trying to match the dense dimensions of the models. So essentially, if you look at the active parameters of our sparse models, they will try to be the same as the active parameters of the dense model. Some other details: trained for 300 billion tokens, context size of 2048. That was standard at the time, and we generally follow the GPT-3 setup. So here's the results, and you'll see here in the red is the dense model, and in the yellow is the sparse model. This is evaluated on perplexity, in domain and out of domain data. And for perplexity, lower is better. And you can see that the sparse model is indeed for the same amount of computation. So on the x-axis here, we have the amount of zeta flops that the model used to train. So you would see that for the same amount of computation, a sparse model was doing much better. Although if you look closely, you may see that out of domain, the gap starts to narrow a bit as the computation increases. Here's the results for evaluating on zero-shot tasks. So this was using 6 tasks that were the standard at the time. Again, we see the same thing, that the sparse model does better, the same amount of computation, and quite sizably so. And we can look at it in another way. We can look at the speed up factor. So we want to know how much faster can a model train to the same level of performance. So we'll compare the sparse and the dense model. So let's say if the dense model achieves 90% on a task in 4 zeta flops and the sparse achieves it in 1 zeta flop, then we'll say that the speed up factor is 4. So we can plot the speed up factors now. You'll see that we almost always see speed ups with the sparse models. You see that there's difference on different tasks for which we evaluate. And you also, if you sort of squint a bit, you may see that at scale that the gap, the speed up decreases. So the conclusions of these studies was that sparse models outperform dense counterparts for the same computation, even at scale. And we studied it at up to 6.7 billion parameters dense and up to 1.1 trillion parameters sparse. But the gap does appear to be closing with model size and computational increase. And improvements seem to be better in domain versus out of domain. So as we were doing this work, some interesting personal learnings for me were, one, that scaling is difficult. A lot of things that work at small scale don't work in big scale, and that we still have not explored sufficiently sparse models. So here's one example of how this works practically. So you can see here on the left, like what our initial results look like. It seemed like were very disappointed. Sparse models didn't do better when we were training at scale. But then we discovered the bug, we fixed it, and we had the chart on the right. So there was a lot of little setbacks in the project like this. And we still don't know a lot about how sparse models scale. There is an extra dimension of sparsity that's in addition to all the other things you need to study when you scale models. There's many unexplored hyperparameters. At the time, Chinchilla was coming out and it was showing us that everything we knew about scaling was wrong. And that even affected more sparse models because you have even more parameters. So if the models that we had at the time were undertrained, the dense models, then the sparse models are probably even more so. But since we actually have had a lot of really exciting developments with sparse models, so we had at least these three models, DBRX, Mixtral and Grok, that are all sparse. They have some level of mixture of expert sparsity, and they do seem to be doing much better than their dense counterparts. And I think there's also a lot more work to be done in terms of the techniques that we use to build sparse models. We had a paper about how we can think of mixture of experts as essentially sparse feed-forward networks. And there's some, if you think of that problem that way, there's some corollaries that come out of it that allow you to do the mixture of experts models better. So there is a link there at a presentation that I gave on that. And I won't go into much more detail because I want to get to the second part, which is the cross-lingual models. So I'll pause here for a second. That's the part on sparse models. If anybody has question about that, happy to take it now.
The last slide, you mentioned sparsing based on specification of the matrices.
Yep.
So have you made a comparison and evaluation between the different approaches of sparsing? I mean, the mixture of experts versus the specification of matrices.
Yeah, that's a great question. So I can point you to our paper. So I think the interesting part was there was shown that you can think of a feed-forward layer as a sparse multiplication, as a sparse. You can think of it as a key-value pair and sort of sparse multiplication, picking up the highest scoring keys, essentially. So if you think of it that way, that's essentially what mixture of expert is, but it does it in a block way. So each key selects a whole matrix rather than one line in your matrix. If you think of it as a continuum, you can actually have blocks of different size and select them. And when you do that, you can get more efficient implementations of mixture of experts. Happy to talk to you more about that, maybe in the break. So cross-lingual models. So this part of the talk, first I want to start by mentioning Badea Glue, which was a benchmark for language understanding in Bulgaria. And this work was done with collaboration with a bunch of Bulgarian researchers in NLP, all put together by Drago Radev, who was a very dear colleague and friend and a really big figure in computational linguistics in Bulgaria. He tragically passed away, but we really miss him. He was not just a really great researcher, but a great human being. So just want to take a second to thank Drago. So multilinguality and cross-linguality, why is it important? I think we heard earlier from Ms. Georgieva that translation in all the languages are very important. In the European Union, as people who come from a small country with a small number of Bulgarian speakers, I think we can relate to feeling less important sometimes. So we want to build models that are working for everybody, no matter what language you speak. When I talk about I'll talk about cross-lingual models. So just to contrast to multilingual models. So multilingual models will refer to a model that can the same model can handle many different languages. So for example, we can have a multilingual BERT model that you can train for spam classification in English. You can train the same BERT model for spam classification in Arabic. Or you can train an LLM that can understand prompts and respond in many different languages. So it can respond in Bulgarian, in English. A cross-lingual model, in contrast, can transfer the learning from one language to another. So if I have a BERT model that I train to do spam classification in English, in the same model without additional training can do it in Arabic as well. Or I can have a LLM that I fine-tuned for instruction following in English and can also follow instructions in Arabic, or I can train it for understanding, for classification, or I can prompt it in English and ask it to respond in Bulgarian or translate English to Bulgarian. So cross-lingual models are crucial to building inclusive NLP tools because you don't want to train your tools for all the languages in which they'll be used. That's just trust me, I was doing that at Meta, and it's just not sustainable. There's just too many languages and too much work goes into training each language for each training the model for each language. So for our work that I'll present today, we train a multilingual generative pre-trained model, which we call XGLM. To provide LLMs for speakers of underrepresented languages. It showed impressive few-shot learning capabilities in medium and low resource languages, as well as strong cross-lingual transfer capabilities. So yeah, the key really is the data that we train it on. We train again the same. So this was about the same time. GPT-3 was the standard bearer in large language models. So we train the same size model as GPT-3. We used more vocabulary, more terms in our vocabulary. So we had models with 564 million, 1.79 billion, and 2.9 billion, and 7.5 billion parameters. We trained it on the CC100XL training data, which was mined from Common Crow, and it included 68 snapshots of Common Crow. So we trained it on 30 languages from 16 language families. We used temperature-based sampling to make sure that we represent sufficiently all the languages. So if you look at the chart here, this shows the distribution of the data that we trained on versus GPT-3, and you can see that we did have a lot more data from the smaller languages, from the tail languages. So one interesting wrinkle here is if you have a multilingual model and you want to test it in many languages, how do you prompt it? So for non-English language, you can have your text, let's say in Chinese, and you can directly apply an English prompt to that text and then try to resolve the task. You can use prompts that are manually written by native speakers of that language, or you can translate from English prompts and you can do the translation either manually or automatically. So again, this was maybe a little bit different because at the time we had prompts for different tasks that were handcrafted, and we would look at the probability of words. But all of that had to be somehow translated So we trained these models and we measured their performance on XNLI, which is the cross-lingual natural language inference task. And here in this table, we'll see essentially how we prompt is in the different rows. So in the top row is we use the handwritten English prompts. On the one under it, we'll use Chinese prompts only, also handwritten, then Spanish and Hindi handwritten prompts. And then we'll use the handwritten multilingual prompts. The multilingual prompts machine translated and multilingual prompt hand translated. And by multilingual prompt, I mean we'll match the prompts to the language in which the task is to be performed. So surprisingly, we were expecting that the multilingual, either handwritten or hand translated prompts will be best, but that's not what happened. So the English handwritten prompts actually perform the best almost always. So simply using the English template performed the best across languages, and that was quite surprising. Actually, subsequent work have validated that, and I think it's something that we still need to understand better and see how we can correct in our models. You can see, for example, in Chinese, you do get almost 15% better handwritten English versus handwritten Chinese prompt. And in Hindi, something similar. We also tried these models for zero-shot machine translation. So this was using the Flores 101 data set, which was covering 14 languages of the ones that we had trained on. So we would do this essentially zero shot. We did use 32 examples, but those are sort of just examples of the task, so the model can understand that it's translating. Interestingly, so two things. First, if you compare our models to GPT-3, you'll see that we were doing quite a bit better across pretty much all languages. And that's reflective of the fact that we did have more tail languages in our training data. And then you can see that also our models are performing almost as well as supervised models. And if you look nowadays, I think that you see a lot less work on pure machine translation because this multilingual large language models are actually catching up to specific supervised translation models. So some key learnings. Multilingual generative pre-training significantly advances the LLM's few-shot learning performance for a broad range of medium and low resource languages. Improving the performance for medium and low resource languages is not only a modeling challenge, but also a challenge in data collection, fairness consideration. We need to figure out how to manage the mix of different languages that go into training the models. There's still interesting work to be done in multilingual instruction fine-tuning. And what's interesting that if you look today at the top proprietary language models, they're actually a pretty good multilingualist. So I can go and ask GPT-3, "Откъде извира Дунава?" Where does the Danube River spring for? And I'll get a really good answer, actually. I can actually say, where does it, "Откъде извира Дунава?" then translate and answer in English. And the model actually does that. It translated my question and it answered it in English as well. So it's also cross-lingual. And this maybe begs the question, why are LLMs natively multilingual? So here in this last part, I want to talk about something a piece of research that I found very surprising and very interesting, and gives a kind of an interesting food for thought. So for a while, we have this hypothesis, and this comes from the world of word embeddings, that embedding spaces actually have very similar shapes. So if you embed word embeddings in English and embed word embeddings in Bulgarian, the embedding spaces will be similar shaped. So if you find a way to align them by using some common words, then all the words align and the two embedding spaces are aligned. So words with similar meaning have, are very close to each other in this embedding space. So this was even the first word embedding ideas, where if you took king and subtracted men and added women, you end up near the embedding for queen, and then that holds across languages. So the hypothesis is that when we train these multilingual models, because there's some code switching and other words that are in common between the texts of different languages, the embedding spaces of these large language models align, and then we get multilinguality. So we actually wanted to test this hypothesis, and we said, okay, well, what if we had some extra anchor points? So if we take some words, for example, we take something like I went to the beach, and we replace beach with the Italian words spiaggia, then we'll be introducing an artificial anchor point. So our hypothesis is if we introduce a lot of these new anchor points, the embeddings will be more aligned. So to test this, we trained BERT models. We added this extra anchor points to a multilingual BERT model. And now we can compare. So the dark blue bars are the original model, and the dark green bars are ones with the extra anchor points. So we'll see for English to Chinese and English to Russian, we have small improvements, but definitely not as big as we were expecting to see. So we said, okay, what if we go the other way and remove all the anchor points? So how we can do that? We can essentially take our English text and tokenize it with one tokenizer, and tokenize our Russian text with a different tokenizer. So even if it's the same token, we give it a different ID. So there's no common tokens between the English and the Russian at all. And then we train a model. And the results we get are the one with the light green here, which are worse than the original model, but actually not that much different, only a couple of points. So what is going on? So we had to actually revise our hypothesis and hypothesize that the internal model spaces have the same shapes, but these spaces are not aligning because of the anchor points, but they're aligning because there's something in the representation. Maybe they're saving parameters that makes it more efficient to represent the same concepts close to each other. So how can we test this hypothesis? Well, let's do now another experiment. So instead of removing anchor points, we'll be removing parameter sharing. So we would take our standard BERT model there on the left, and we'll start splitting off layers. So we would say the first layer, we'll use 2 copies of it, and the 2 won't be shared, but they won't fit in the same second layer. And then we'll split the second layer and so on. So the more layers we split, the less sharing there is between the 2 models. And then we'll see what happens to the cross-lingual performance. So this was done in a 8 layers BERT model. And you can see if we split, so I think first we just split the embeddings in the dark orange, we lose a bit of alignment. Then we split the first 3 layers and we lose some more. And then if we split the first 6 layers, so we only have 2 shared layers and 6 separate layers, in that case, we get the performance that's pretty much random for tasks for Russian and Chinese. So that seems to validate our hypothesis that because they're trained in the same model and shared parameters, that actually leads to the alignment of the spaces. And compare this to anchor points, where removing all the anchor points only leads to a couple of points of degradation. I think that makes a pretty strong argument. You can also see that the word embeddings that the model learns are as good as what we used to do to artificially align embeddings, word embeddings with fast text. So I won't go into much detail, but if you just get the embedding, take the embedding tables out of BERT, it's already pretty well-aligned multilingual embeddings without having to do any additional alignment. And we can run another experiment. So here we compare a monolingual model in which each model was trained separately on the same training data, to a bilingual model where one model was trained on a joint training data. And again, we'll remove all anchor points. We actually can train two English models. So you can think of, we have subdivided our English corpus into two, and we have tokenized it with two different tokenizers. So there's no overlap between the tokens. They look like two completely different versions of English. And you can see that if we compare the bilingual and monolingual, so what we compare here is essentially we take a sentence, you compute its internal representations, and we look for the similarity of an English sentence and its equivalent, let's say, in French. So we use parallel data for that. And we see that when we train models jointly in the same model, the bilingual models have much better internal similarity. And we can compare those to a random model in which we use random weights. So there's still some similarity due to some interesting properties of these models. So I think, again, for me, this was a very interesting finding and sort of mind-boggling finding, that because essentially when you think of it, we take two set languages in or text in two completely separate languages. We don't know anything about them. We don't have any grounding. And yet when we train the same model, it aligns them together, which means that if you think of it, if today we found some lost language from a long time ago that we don't know how to speak, and we have billions of tokens of it, we can fit it together in our LLM with English, and somehow we will learn to speak that language. So some of the conclusions from this is that we don't need parallel or code switching data to train good multilingual models. We can use LLMs to do transfer from high resource to low resource languages, as long as we have enough data in the low resource language to learn this internal representation space. The high resource language can actually help. And also that means that maybe as the model size increases, we have to worry less about including a lot of data from low resource languages. But yeah, but still we need to have at least enough text from the low resource languages to build good internal representations. So I think there's also some interesting scientific applications that, this argument, is there any universality of language? So maybe there is universalities, but maybe they're learned rather than, being native. And I think one other question that for me is very interesting is whether there'll be universalities across domains as well. So if we learn representations of images, would they be the same representations as the representations that we learn from text internally? And could we sort of align text and image without necessarily needing to do grounding? So interesting to see whether we can do any cross-model transfer the same way we do cross-lingual transfer. So yeah, my research interests making LLMs practical nowadays. I work a lot on the flip side of large language models, which is how can we make them work for everyday work applications, and sort of the engineering challenges around that, as well as the applied research challenges around building really high quality models, being able to work around some of the model's deficiencies, such as, not always being truthful to their inputs and so on. But I'm still interested in sparse LLMs, in multilingual LLMs, as well as instruction fine-tuning. Yeah, I think that's all. I wanted to have some time for questions in the end. So thank you all for your attention. I'm happy to hear questions.
So you have concluded that it is not necessary to include parallel corpora in training, but is it improving that is worth it, including it if one has it?
Thank you. So I think in my experience, we haven't seen notable improvements from using parallel data. So this actually even goes back to work that I've done on large cross-lingual language models. So we had a model called XLM, which was at the time sort of the biggest version of BERT and Roberta trained multilingually. And for it, we also tried using parallel data and having a training regime in which we do include some parallel data, but it didn't bring any improvements. So I think that as we increase the capabilities and the size of the models, we need less and less parallel data, because there are these universalities that the models can pick up. The way that I think of it is, if you have a human being learn, English and learn Russian, they can probably do the translation without having to see a lot of sentences translated from one language to the other.
One other question. If we are translating between two sparse languages, would it be helpful to have some language with a lot of resources into training model like English?
I think so, yes. And I mean, I think that I want to caveat all of that you still need a significant amount of in-language data and in high quality in-language data to be able to train good models. And for a lot of languages, we don't even have that. So for those, definitely benefit from having a parallel data. I think there's a question in the back. Oh.
Nobody?
I thought you were raising your hand, but maybe no. Over there. Over there.
As much as I heard so far, you've got some more difficulties in translating from English to Russian and vice versa. And that's because the grammar of Russian language is much more different. So have you thought of some approach, maybe if you try to make the large language model make an artificial language that shares grammatical characteristics of Russian language and English language, if you translate first to that artificial language and then to Russian language, can you minimize the error more? That's my question.
Yeah, don't actually feel qualified answer that particular question because I haven't done much on artificial languages or studying the grammar in that depth. I would just add that in my experience as researcher, like usually, we saw over a long term that the simpler models that are text to text and we feed them more through scale, but kind of limit all the other modeling enhancements that we build into model. Those seem to win over time because they are essentially giving the neural network the capability of learning all these things and representing them internally. So I would expect that that could be something for language with low resource that could be useful, but then as more and more data and larger models become available, eventually that will be the way that you get the high quality models.
Okay, more questions? Maybe later during the break. Let me take one more time.
Thank you.
Now we continue directly with our fourth session. Professor Stoyanov is going to chair.
Dear colleagues, we have today in the morning session 3 presentations. We have this morning 3 presentations, and I'm glad to introduce the first talk, which is titled A Cross-Model Study on Learning Romanian Parts of Speech with Transformer Models, which will be presented by Verginica, Barbu, Mititelu. Please, the floor is yours.
I will make this presentation, which is the result of a collaborative work. This work is carried out within in an internal project, which focuses on finding out how these large language models learn different NLP small tasks. And the focus of this presentation is how they learn part of speech tagging, especially for unknown words. So, okay, just a moment, just a bit, good. So it's this era that we are living today of large language models, of transformers especially, that have changed a lot the way in which NLP algorithms deal with with language analysis. And with this attention mechanism, a word-to-word matrix of linguistic relevance, morphosyntactic and semantic, that is learned from raw texts. These models appear to learn, we say, any language when trained on billions or even trillions of words. And when we fine-tune to an NLP task, for instance, post-tagging, named entity recognition, dependency parsing, or others, the transformer models achieve state-of-the-art performance, and so they behave quite well. But why exactly are these models so good at seemingly any NLP task? This is a question that we, or most of us, ask, but the research on this topic is scarce at the moment. With this presentation, we add to the research explaining the inner workings of transformer models by conducting a cross-model study of the post-tagging capacity of these models. More exactly, we aim to provide empirical evidence supporting the hypothesis that transformer models learn the post labels of unknown words, which are words not seen during the training phase, and investigate if there is a cross-model similar learning behavior when it comes to learning part-of-speech labels. The presentation of the experimental setup now. We use the available Romanian BERT model from Hugging Face. They come in three different, so there are three different models, actually, the small, the base, and the large one. And there is also a BERT model available that was trained on Corolla, which is the Romanian reference corpus, which contains texts from different styles, genres, written and spoken language of contemporary, from contemporary data, which covers more than 1 billion words at the moment. And what we do is to fit the output layer of the BERT models with a post-tagging head with 35 morphosyntactic categories. And we fine-tune this augmented model by training on the Romanian reference tree bank, which is a tree bank annotated according to universal dependencies principles. Those of you who are familiar with these tree banks know that all or most of the corpora which have a reasonable size within this project are split into three parts: the training, the dev, and the test sets. And for Romanian, for which the corpus has about 210,000 tokens. The training corpus contains about 185,000 tokens. And here we use the dev and the test parts together for testing. So about 33,000 tokens. The starting learning rate parameter is set at 10-5, and it is decreased by a factor of 0.9 every epoch. And there are 5 training epochs in the experiment. And we compare the accuracy on the post-labeling task for unseen words versus words that are rarely seen using the odds ratio statistic. We notice that rare words are mostly content words, so nouns, verbs, adjectives, and adverbs. And to make the comparison between unseen words, so those that have frequency 0, and rare words fair, we will only consider evaluating part of speech labeling of content words. This is in this table we have the distribution by frequency. For the test set, so the dev plus test set in the UD tree bank. So we have about 3,000 words, content words that have 0 frequency here, so unseen in the training set. And F1 means only one occurrence, more than one occurrence in this. Now, we use this odds ratio to measure how likely it is that the accuracy of post-labeling of unknown words, so not seen during training, is like the accuracy of known words, those that are seen during the training phase. Our claim is that if the transformer model does indeed learn the part of speech of words, it should be as accurate on unseen words as it is on unknown words. And the odds of being correct is calculated as the probability of being correct. So the accuracy divided by the probability of being incorrect, the error rate. The odds ratio between unknown words and between known words and unknown words is calculated as the odds of being correct on known words divided by the odds of being correct on unknown ones. So the odds ratio should be around 1 to verify this claim. So what we see here, this print shows that Isaac was actually chosen only for the results obtained for Robert's small, so the small data set. But the results for all three data sets are actually similar. That's why we chose to present only one. In orange here, you can see the low value of confidence interval. In green, the high value of the confidence interval. And what we have in blue is the odds ratio between known words with shown frequency, so F larger than 0, and unknown words, those with frequency 0. And we see that the odds ratio is between 1 and 1.4. These are the results when using the model that was trained on our corpus, on the reference corpus. And here the odds ratio quickly rises above 4, which means that can do better parts of speech tagging only on seen words. And these are actually some results that that are similar to models that are under-trained. And that's because of the difference in size of these data sets that were used. Well, when looking at a cross-model behavior, the research question is, are there dimensions of the BERT output vectors that are the same across models and that are responsible for the learning of a particular part of speech? And for the comparison, in this experiment, we used two BERT models with the same number of output dimensions, namely 256. This was the Robert Small and the BERT that was trained on Corolla. And for each word in the test set, with its part of speech category, we extract the top 10 dimensions of the BERT output vector that contribute the most numerically to the classification of the part of speech category. And for each part of speech category and dimension D, we compute the conditional probability over the whole test set, and we sum it over the common dimensions of each category. The dimension overlap probability mass is small, which means that the part of speech information is not encoded in certain dimensions in different models. And from these small experiments, we can confirm that properly trained BERT models learn the parts of speech labels of unknown words by obtaining the same accuracy on unseen words as on known words. We could not replicate the learning behavior of part of speech labels across BERT models. And this part of speech information seems to be encoded differently in different contexts of the same word with a given part of speech. And there seems to be an optimal number of parameters of the model that best suit part of speech label learning. And in our case, the best model was Robert Pais. So not the larger model, but this Pais, let's say, version of it. It seems I was quite quick. And that was the whole presentation. And unfortunately, if there are technical questions, I cannot answer them. So I urge you, because in this presentation, only a few of the results were presented. Some more tables and figures are presented in the paper. If they are not sufficient for your understanding, I urge you to address the first author, my colleague Radu, whose email address is available in the paper. Thank you for your understanding.
We have plenty of time for questions. Any questions?
Okay, thank you for the nice talk, and I will try to ask questions for linguists, right? So first, you mentioned that there are 35 categories of parts of speech, and I'm curious whether this is the part of speech with some grammatical features. This is the one, and the other, if you have some information. I'm always interested in error analysis. Can you say in which parts of speech or which combination of a part of speech with grammatical features is the most difficult for the model?
Okay, as far as the first question is concerned, so there are those, let's say 10, we have in our grammar 10 major parts of speech, but we consider some, let's say, refined forms of them. So for instance, nouns are divided into proper nouns, common nouns. Then we have different abbreviations for which we use a different tag, and depending on their part of speech, you have nominal abbreviations and so on. That's why the number of parts of speech is so high, 35. So then verbs, we treat differently, auxiliaries and modal verbs and so on and so forth. So that's why we reach 35. As far as the error analysis is concerned, I remember your mentioning yesterday about error analysis. Unfortunately, we haven't done this step systematically. So to look at extract information about which of these categories are harder to learn. Also, I think, well, the data is not that small after all, so we could have done this, but we haven't done it. It's not even in the paper presented, but this is probably something that we should invest time in for clarifying better some things. Thank you.
Thank you.
Other questions?
Just one clarification. When you're saying unseen word, you mean word from which the model has not been fine-tuned on POS, not the words which are not in pre-trained?
No, words that are not in the pre-training phase.
Oh.
Yeah.
Interesting.
Yeah.
I have a question. Yes, I'd like to ask you, I was wondering, have you made a comparison between Romanian and, for example, English part of speech learning? I mean, for English, you have enough data so you can...
Well, it's a project dedicated to Romanian. So all experiments we are carrying out are focused on Romanian. That's why there is no comparison with other languages presented.
Yes, I understand.
Yeah, we haven't done this. No. Yeah.
Okay. There is...
Speaking about Romanian, it's quite interesting language because it shares common characteristic with Romance languages and typical Balkanian languages, if I may say so. And so have you thought what part of your Romanian grammatical characteristics you were talking about are the same, for example, as those in Bulgarian language, and what are more Romance ones?
Well, from what I understand, the question is related to PETIAs. Yeah, so we haven't carried out any investigation in this respect. But this could be an interesting kind of continuing actually the investigations. Thank you.
Just giving the idea.
Yeah, thank you very much.
Okay, if there are no other questions, let's thank you again. Thank you. Okay, it's my pleasure to announce the next talk, which is titled "What do BERT word embeddings learn about the French language?" which will be presented by Ekaterina Goliakova.
Hello, everyone. My name is Ekaterina Goliakova, and today I'm a representative of University of Lorraine and the Research Center Laureate located in Nancy, France. Before we start, I want to give a brief motivation to the project. So we work with BERT models, but first of all, what BERT models stand for. BERT is a bidirectional encoder representations from transformers, which as of the date of me preparing this presentation had over 110,000 citations, the number which I constantly need to update, which we can consider to be an industry standard in the field of natural language processing. However, it is used in various cross-domain fields like text-to-image, text classification, protein structure prediction, which I unfortunately won't be able to give a lot of details on, but it's just interesting to know that the BERT models found application in so many very different fields. However, BERT being a small large language model still is a large language model, and interpretability of parameters of such models is still a challenging task. I also want to direct your attention to several trends that are prevalent right now in the field of natural language processing. Despite this graph being a very old one for our domain, it is dated by 2020. What we can see here is that the number of parameters started exploding around 2019, and right now commercial level models can have hundreds of billions of parameters. On the other hand, some researchers predict that the training data, especially high quality training data, will be exhausted in the coming decades. With this in mind, we propose to direct our attention to existing models and try to understand better what information is encoded in the word embeddings. For this, we propose a metric called inf-enc to compare embeddings produced by different models. And outside of the scope of this presentation, we attempt to identify dimensions of the word embeddings that encode target linguistic information. French being a relatively high resource language, we were lucky to be able to choose different models to work with. So here is the list of the models that we worked with. What is needed to be understood is that FLOBERT and Common BERT models were trained only on French data, while MBERT and XLM Roberta and DistalBERT are largely multilingual models. Here, all the models are sorted by the number of parameters, with the smallest models appearing on top and the largest models appearing at the bottom. And you can see the range of parameters, even though it can reach 500 million parameters, is still relatively small by today's standards. So right now I want to talk about our dataset pipeline creation, how we worked with the obtaining word embeddings. For this, we took a word from French vocabulary, for example, épice, which stands for spice. It was passed to a BERT-like model for tokenization. We obtained the tokenization results removing CLS and beginning of the string tokens, as well as SEP or end of the string tokens. We only retrieved the token related to the word itself. We retrieved the weights of the last layer of the model. And by this, we created a neat table of words with the values of all dimensions. What needs to be highlighted? With this approach, we decided to remove words with multiple senses because the French language has a variety of words that can be both, for example, nouns and verbs. And since one of the target features of interest was part of speech, we decided to remove this ambiguity and keep only single sense words. Additionally, as can be seen in this pipeline, we were picking only one token for the word. So if a word was tokenized in multiple tokens, we decided to disregard this word for the scope of this project. However, we believe it needs to be considered in the further work. And additionally, invariable words, so the words that do not have a gender or do not have a plural form, were disregarded as well. So with this cleanup, using the Morpholu lexical resource, which is a vast vocabulary of French words, we obtained much smaller vocabulary of our own, because either some words were tokenized by multiple tokens, or they were invariable, or and so on and so forth. What needs to be understood here? So in orange, or I don't know how this color is looking on the display, we highlight the models that were trained only on French language. And as one can expect, we managed to retrieve much larger vocabulary for the models trained only on French language, because large multilingual models need to dedicate space to a lot of languages, not only to French. Therefore, we retrieve much less words related to French there. However, what needs to be seen here, despite that FlowBERT small and Common BERT base having relatively similar sizes, we can see that Common BERT base produced smaller vocabulary, and this can be potentially linked to different tokenization types. For example, FlowBERT uses byte pair encoding for the tokenization algorithm, and Common BERT base, don't want to lie, sentence piece. So as we can see here already, there is a big difference in how models are behaving. So having obtained the vocabulary, we propose this pipeline. We create a binarized linguistic feature. We find sets of dimensions that are most likely to encode the feature and compare different models. So how do we create binarized features? Since the scope of the project was relatively small, we picked a small subset of linguistic features. So gender, number, part of speech, and two semantic categories, act and person. Gender, number, and part of speech was conveniently already provided by Morpholu, and act and person semantic categories were extracted from another resource called Sequoia. So just to give you a visualization how the binarization happened, it was one hot encoding of each categorical feature. So basically we had a feature called gender feminine, gender masculine, number plural, number singular, and so on and so forth. And in total, we had 11 features. So combining all our dimensions and all our features, we propose two types of tests. We propose dependency type tests and interestingness tests. So I will talk about this more right now. So what are dependency tests? So here we want to test if a certain dimension, so as you can see, we take dimension across all the words or vocabulary, and a certain feature are independent. For this, we try first ANOVA test with p-value below 0.001. So for ANOVA test, we split the dimension in two groups, one associated with feature vector values equal to 0, and another one with feature vector values equal to 1. So we have these two subsets, and null hypothesis is that means of these two groups are equal, and H1 would be that means are actually not equal. So if the means are not equal, we can assume that there is some sort of effect of the feature vector on the dimension. And for mutual information, it is more straightforward. We just take the vector dimension vector and the feature vector and compute mutual information. If mutual information is higher than 0, we consider that there is some sort of dependency between the vectors and add this dimension to the set of mutual information dimensions. So as you can see, we here have two sets of dimensions, ANOVA dimensions, mutual information dimensions, and then we decided to ask what dimensions are found by the both tests, and found an intersection of this and dependent dimensions. There is another type of question we can ask. What are interesting dimensions? So for this, one of the ideas was to train a classifier, retrieve the weights related to each dimension, rank them, and get top alpha %. Because here, unlike for dependency tests, there are no clear guidelines. What is the cutoff for dimensions that we need to use? So we decided to use a changeable parameter called alpha. So for the classifiers, we use logistic regression and perceptron. And similarly, we checked correlation between dimension and the feature vector and used the same alpha % cutoff. So we tried different alphas, 1%, 5%, 10%, 25%, 50%, and 75%. And similar to dependency tests, we tried to find the intersections of these sets as well for each alpha. So with these approaches, we had 27 subsets of dimensions for each feature. And we would use these subsets to predict the value of feature vector on unseen data, choose the best subset of dimensions and its best achieved accuracy. So this would be our target metric in FEC. Since the datasets were relatively small and we wanted to avoid any sort of biases, we decided to use 5-fold cross-validation. So all data was separated in 5 folds and tested on the unseen fold. So now we can go to the results. So first results are in regards to number. So as you can see here, the subset that we retrieved for FlowBERT large generates the accuracy of 0.956, which is quite significant and quite comparable to all dimensions. So here, the accuracy for FlowBERT large on nouns was achieved on subset of 100 dimensions out of original 1024 dimensions. Another interesting point here is that FlowBERT large with the rank 1 shows comparable results to FlowBERT small, one of the smallest models. Another point that I want to highlight here is that DistilBERT, the largely multilingual model, a very small model comparatively, shows results that are comparative to FlowBERT-based models that were trained only on French language and are larger. So overall, the size of the models doesn't appear to be predictive of performance on this metric, and as well as training data, whether it's multilingual or not multilingual, appears to be not predictive. Another thing that we can see here is that Common BERT Pais, the French model, shows quite poor results. And once again, we can bring this back to the tokenization differences, and we will discuss this a bit more later. So if we compare the gender results, we can see that there is a drop from what we saw before. Before we saw that a Flaubert large generated 0.956 accuracy, and here it dropped to 0.895. First of all, one of the explanations for this is that number is much more formally deductible from French words. So, for example, ending on S or X can be easily understood by models and by tokenizers, while gender is much more elusive concept and needs to be understood either by combination with articles or adjectives. So here the results drop significantly. And here we see the same trends that Distelbert shows comparative results to Flaubert small or Flaubert base. Flaubert small shows comparative results to Flaubert large, and Camembert base performs quite poorly. If we have a look at part of speech, the results here are slightly better than for gender. However, we can see here the first interesting part is that Flaubert small, the smallest model, achieves the highest results for detecting adjectiveness of words among all models. So if we go from more grammatical features to semantic features, here results are even poorer. And Flaubert small, once again, performs the best on both tasks, with the Flaubert large showing the worst results out of all previous features. Now one can ask whether or not these numbers or this metric is representative of anything at all. So here we compute the correlation of the InFanc results with the classification. And as we can see, it's pretty high. And as you can remember, we used logistic regression in our dataset selection. So here it is represented by LR, and funnily, it's one of the lower results that we can see here in correlations. And one can see that MB, that stands for naive bias, shows highest correlation with InFanc results that we have ever seen. And similar to the numbers that we saw before, InFanc correlates more poorly with semantic information like semantic act and semantic person, which can be a signal of ambiguity of this feature. So I want to highlight that this was a very small scale project that had tons of limitations. First of all, we only investigated BERT-like models, so we didn't investigate any other architecture. And second of all, we only investigated French language. Secondly, the set of linguistic features is limited. Thirdly, BERT models are famous for changing the representation, the word embedding, depending on the context. And in our situation, we disregarded this due to limitations of the project, but this needs to be considered in further research. And the last point, and I think one of the most important points, is the impact of the tokenization needs to be studied. Why Camembert performs much worse than Flaubert, even though they were trained comparatively the same. So some main takeaways. So smaller models can perform on par or better than bigger models, as we saw with Flaubert small. Multi or single language models can achieve comparable results. So this is what we saw with Distelbert and Flaubert base. And tokenization appears to have a significant impact on the encoding of target features. The highest results were observed for number encoding. So yeah, whether or not the words have S or X in the end appears to be easiest task. For most models, the achieved InFanc for gender is higher for adjectives than nouns. For most models, the achieved InFanc for part of speech is the highest for nouns. And for semantic categories like person and act, the InFanc scores and the correlation with the classification results becomes lower. So this is overall what I have. And now to the question.
Let's think about it.
about the applicability of this research? For example, we're dealing with models that some of them are multilingual, others have versions in other languages. Does this kind of explainability maybe have potential to improve performance when it comes to differently working languages, such as languages that do not have gender or number or other differences?
So in my point of view, one of best applications we can find for this is the part that unfortunately I didn't have time to cover, is finding the dimensions that are producing these best results. Since we are operating with multiple sets, what we can find is a dimension that appears in the sets constantly throughout the 5 folds. So once we have these dimensions, what we found is that on these dimensions, we can achieve results that are comparable to using the full model. So what this method could be useful for is for ablation, knowing that only this part of the model matters. Back to your question to the languages that don't have number or things like that. I believe that this approach can be used to any linguistic feature that can be binarized. So overall, this is more of a framework than anything at this point.
Questions?
Do you think that the way the French language works with complex words, for example, pomme de terre, makes the tokenization process more convenient and better, so that the French-only model achieves the best accuracy in your research?
So for our research, we conveniently disregarded the multi-token words. So pomme de terre will be one of such words. So we only kept the core vocabulary, single token words, single root words, single sense words, and compared on that. But yeah, this is definitely next question, because not only pomme de terre, but even when facing more complex forms of verbs, BERT models tend to tokenize first the root and then the suffix that corresponds to the correct grammatical form of this word. So this, how to better to combine these tokens, this is the next question that needs to be answered by our project. But yeah, this is outside of the scope now.
Other questions? Questions? I was wondering, in order to eliminate the dependency on the tokenizer, have you tried to apply, for example, some approaches like byte pair encoding or word pieces, etc., which are now commonly used for language modeling?
Yeah, so since the point was to compare the existing models already would use, so that's what I mentioned, FlowBERT uses byte pair encoding, and Common BERT uses sentence piece. I don't remember well enough what other models use, but I think word piece and sentence piece are frequent. So we didn't want to alter how these models work, but yeah, it would be an interesting question to compare the impact of tokenizer as the continuation of this research.
Okay, if there are no other questions, please thank again to our speaker. Okay, it's my pleasure to present our last talk for the morning session. It's titled Whisper TAD, a general model for transcription, alignment, and diarization of speech. And the talk will be given by Camille Lavigne.
Can you tell me how to pass the slides, please? Oops. Oh, no, it doesn't work. Okay, so it is. Okay. Hello, everyone. My name is Camille Lavigne. I'm studying currently at the Université de Lorraine in France, and I'm going to present you the paper that I wrote with my friend Alex Tasica, who is a student at the Utrecht University. The core idea of our paper is to build one model that can solve the three main tasks of automatic speech recognition, which are namely transcription, alignment, and diarization, plus voice activity detection, which in fact is part of the diarization process. I think everyone is fine with what is transcription, so I'm not going to define the term. Alignment, I'm not going to talk a lot about it because it's not the main focus of this paper, but it's part of the model we used to solve the task. So I want to say that it's possible to do it. And then diarization, which is the main focus of this paper, plus the voice activity detection, which is the task that aims to recognize who is speaking in an audio recording. The whole process of transcription, alignment, and diarization can be referred as diarization, augmented speech transcription. This is the problem we want and try to solve in this paper by fine-tuning a model, which is called Whisper. Maybe some of you are already know this model that was pre-trained by OpenAI and is freely available. And we try to solve this task with a fine-tuning process so that it's more efficient regarding the small dataset that we had. I'm going to first try to give you a sense on why it is important to have only one model to solve these three tasks together, and a really brief history of what has been done in the past about it, then the methodology and the results, and I will conclude with more of an open talk about what can be done to get better results than what we have obtained so far. Because to be clear, this is not a finished product, what I'm going to present you. It's more of a first step toward a model that can solve these tasks and potentially with state-of-the-art results. So first, very important question, why performing the DAST with only one model matters? First, because one of the obvious benefits is avoiding propagation of errors. If you know the current pipeline in speech processing that are able to do the transcription, alignment, and diarization, these are quite complicated pipeline because they involve three different models that solve the three different tasks. And then you have to combine all the output of all the models to get the final result of the transcription, diarization, and alignment, which is not convenient because if at one step of the process, one model fails, then in the rest of the audio processing, the pipeline may not recover from the error. So one model may avoid propagation of error because the model should be consistent with itself, and even if it do errors, it should be able to recover from it because it has a general knowledge. The second obvious benefit is simplicity of the framework, only one model. And this is very important when we are talking about programming and putting stuff into production, because simplicity is the key to have a better experience when debugging and implementing. And last, but this is still kind of an open question because I didn't have the computer resources to fully answer the question, which is better performance. Why? Because you are combining the three key knowledge about human speech, which are who is speaking, what he's speaking, and when he's speaking. Quickly, very briefly about the past research. The problem is that right now, most papers in speech processing are focusing on only one aspect of the problem in DAST. For example, you will have one team of researchers that build one model to do the diarization, and they are often not trying to solve all the problem at once. Also, most of the papers are quite old, and at least what I found is that they didn't use the state-of-the-art architecture, the transformer architecture, and it's very recently that we have seen papers that try to use this architecture to solve the whole problem in one step with one model. So our methodology, we have one model, Whisper, which is processing an input. This input is a male spectrogram because it is the standard output for this model. We didn't change the input at all. And then what is interesting is the output, because this output is going to tell you all we need to know about the transcription, the alignment, and the diarization. This is why we use three types of tokens, transcription tokens and timestamp tokens that solve the transcription task and the alignment task. These tokens were already present in the tokenizer of Whisper, because it can already do this task. What is really important is the speaker token, which is added to the tokenizer to be able to perform the diarization with this model. A little of terminology also. We used serialized output training to fine-tune the model, which means that instead of having, for example, one model and three head with three different outputs and three different loss function, you only do the training with one head, one output, and one loss function. Now, we also choose to use the first in, first out solution to output the tokens. So it means that the tokens are outputted time dependent on where when the utterance was said in an audio recording. And then the trickiest part to explain, I think, in this paper is the local end-to-end DAST, because Whisper can't process more than 30 seconds samples, which means that if you have, for example, 1 hour of conversation, you need first to cut into pieces your audio recording so that you can process each of the sample of 30 seconds and then combine all the results for all the samples to get the final result. And ideally, we would like to the result to be global, but in our framework, for diarization, it is not the case, which means that if you have one speaker if you have one speaker who is speaking in 2 different samples of your audio recording, the framework is going to give one speaker ID in the first audio sample, and in the second, the speaker ID that is going to be attributed to the same speaker may not be the same as in the first sample, which again means that the diarization task is solved locally. Now, a little more of methodology. We used the AMI dataset and the ICSI dataset because it was quite convenient. These datasets provide the information not only about the transcription, but also about the speakers and the timestamp where when a specific word was said. You can see that in total it's around 160 hours of training, validation, and test data, which is not that much, considering that we are trying to fine-tune a model on 3 different tasks, and knowing that one of the tasks was not implemented with the original model. Briefly about the metrics, we use the standard diarization error rate for the diarization, the EER for the voice activity detection, and the CP-WARE for the transcription, which is kind of the same as the WARE, but it's focused not on the whole transcription of your audio recording, but on the transcription for each speaker in the audio recording. Now the results. First, we can see that clearly Whisper is able to be fine-tuned on these 3 different tasks together. We can also see that obviously the larger the better, but there is a caveat to that, which is that we can see the difference between the results obtained by Whisper Small and Whisper Medium are not very large, which, as far as we understand what we have done, means that we didn't have enough training data to really leverage the power of a larger model like Whisper Medium. We also tried to answer the question, if we train a model on these 3 different tasks, will it decrease its performance in other tasks compared to a model that was trained on a specific task? And unfortunately, I didn't have the computer resources to do the whole baseline analysis. We at least managed to compare the performance in terms of word error rate between the pre-trained model and our framework, WhisperTAD. And we can see that at least for the word error rate, it's clear that there is a large improvement between the pre-trained model and the fine-tuned model. But what would have been interesting, I think, would have been to also compare a fine-tuned model, but only specifically fine-tuned on the transcription task, and see if the fine-tuned model on the transcription task was less, equal, or more efficient than our framework that was trained on these 3 tasks together. Yes, and again, you can see that the difference in performance between small and medium is not that large. So again, it seems to point to the fact that we lack data to leverage the power of larger models like Whisper Medium, if not Whisper Large. In conclusion, I think we can say that Whisper still seems to be a good candidate to solve the DAST problem, showed decent performance in all the metrics that I showed you, even though I know that the baseline are not that strong and it needs further research. And because you can do it in a fine-tuning manner, it may be able to be used for low resources languages. So we plan to try it with larger models, and we would like still to try to do it with little data, which means data augmentation. This is the part that is very tricky and time consuming to do, but hopefully we will do it and then maybe reach the SOTA later with further work. Thank you for your attention. And if you have questions, I will be more than happy to reply to them.
We have enough time for questions, so we divide questions now.
Have you thought about the following problems? For example, when I'm talking in a noisy environment, how would your model react? This is the first question. And the next question is about different French dialects in different regions. Is your model well enough to cope with all of them? And for example, silent letters, homonyms, etc., etc.
Okay, two great questions. Thank you for that. First, unfortunately, we didn't try it on other languages than English. We hope that because of the overall knowledge of Whisper of different languages, I think it was trained on 96 languages, if I'm not mistaken. So it may be able, like was said by the other person that presented before, that it has overall representation of different languages. So it should work, but we didn't test it. Yeah. And can you remind me, please, the first question?
About the noisy environment.
Yes, noisy environment. So again, we didn't work on this specific question, but in the original paper of the Whisper publication, they tried to answer this question, and they showed that Whisper was more robust than, for example, WAV2VEC, if you know what is WAV2VEC. So maybe ours is still robust, but with fine-tuning, you never really know what the model is going to forget. So I can't clearly reply on this point. Thank you for your questions. Yes?
Have you thought how would you solve the problem of recognizing in whole, just not 30 seconds interval, but how would you recognize one through whole transcript, one person?
Okay, so for phone calls or in general, the question? Okay.
How transcript, how would you recognize?
Okay, so it's done by first cutting into pieces the audio recording, okay? Then you feed the first sample to the model, which gives the output of the model. And then for the next samples, you don't only feed the input mail spectrogram, you can also feed the transcription that was already done by Whisper, so that you can leverage the LLM capabilities of Whisper to get a better transcription. Does it reply to your answer?
If one person speaks, then second, and then we cut, and then this first person speaks. Okay, so we have one person speaking, then he marks him as the first person, as I seen on.
Yes.
Then second speaks.
Yes.
And then we cut, and the second continues speaking, and then the first. How would that mark? Would that be first person, second person, or first person, second person again?
In one sample or in the whole conversation where the conversation is cut? Sorry.
Sorry. Okay, so the first person is speaking, then the second person is speaking, then conversation is cut in a and then the second person continues speaking, and then the first person replies to that.
Right, but when you say it's cut, the audio recording is cut, and then you have a second audio recording, or is it all in the same sample
Yes, same sample, but
same sample. Okay.
But those 30 seconds we have.
Okay, maybe I can show this again. So it was what I wanted to explain with the first in, first out solution, which is that in the audio recording, you have utterance, obviously. And the way that we do that is that we diarize and put timestamp on each utterance of the audio recording, and then the outputs the utterance in order in which they appeared in the audio recording. Does it reply to your questions?
Okay. Yes.
Other questions? I wanted to ask you, I was a bit confused about this CP word error rate. What exactly does it mean? Because the general word error rate for Whisper is significantly lower than what you thought.
Yes, so the problem is that when you are trying to solve both diarization and transcription, you can't use directly the where, because as you can see, we have tokens that are not transcription tokens. So we want to only focus on what is in each utterance for each speaker and detach the metric results from the overall transcription, and really focus on what is the word error rate by speaker, not the word error rate on the whole transcription. There is literature about it. I don't have the paper in mind, but if you want, I can point it to you later.
Yeah, okay. Okay, thank you. Okay, if there are no other questions, we have 15 minutes more for the coffee break. So let's thank again to our speaker. And we have coffee break now.
Всъщност, аз като говоря през да.
Jest 4A.
Da.
Втората версия, нали, че бях изпратила две.
Good morning. Welcome to this still morning session, lunchtime approaching, but now is very interesting session about large language model in analysis and generation. And the first talk is going to be presented by Iglika Nikolova, and I will give her the floor to present what she will talk about and all the co-authors and so on.
Hello. So the topic of my presentation is contemporary large language models and literary abridgment, or the generation of versions that are suitable for, let's say, an audience of children or foreign language learners, and to what extent contemporary LLMs such as ChatGPT managed to generate such versions as of today. So I will provide a small background about literary abridgment. I will present the utilized texts, the investigated LLMs, the different abridgment scenarios that they have been tested on, then the evaluation methods and results from both automatic and human-based evaluation, and I'll wrap up with conclusions and future directions. Why abridgment? So first of all, reading for pleasure and at school, as we can sense intuitively and as has been proven, is academically and socially beneficial. Unfortunately, however, there has been a significant decrease in this practice in recent years. And the cause is an interesting vicious circle of the so-called Matthew effect, when the difficulties in reading are aggravated by the fact that they cause a lack of motivation too. So it is hard to start reading again. And here is where abridgment is supposed to come to the rescue. Currently, there is no particular NLP task such as abridgment that is tested. However, it does imply several established tasks, such as the use of long context, which is still pretty challenging for some large language models. There are existing limitations, such as the problem of a model focusing on information that is situated either in the beginning or end of the text, the so-called lost in the middle problem. Then the task of summarization, which is probably the most closely related one to literary abridgment. This is a task that is most commonly related not to literature or aesthetics, but to the reducing size of large amounts of data, such as news data, in order to be processed more quickly and more easily. And finally, creative or literary writing, which is a little bit of a controversial task for large language models. And it opens deep questions, such as about the nature of creativity. And as of today, large language models are most commonly used for subtasks that aid the writing process, such as the creation of a certain character or their characterization. The languages that the research focuses on are English, which is a category of its own, a higher resource language, French, and a lower resource language, Bulgarian. The utilized texts that will be used for abridgment will be the main one, The Little Duckling by Hans Christian Andersen, which is a very well-known, quite short but eventful story that it has been done on purpose for the original text to be taken in a different language originally from the ones that are being examined in order to avoid the variable of translation versus original text. It was originally written in Danish. And then there are also abridged versions, professionally crafted abridged versions of this text in all three languages. And then there are a couple of secondary texts. The first one, The Little Match Girl, also by the same author and with similar characteristics, is used in the one-shot scenario that I will mention in a minute. And then The Gift Under the Bush is a story that has not been published anywhere. So it is in order to test the possibility of the models haven't encountered already the little duckling during training and this influencing the results. But it is cute little story. I'm a bit partial because it's my son who wrote it. The investigated models are ChatGPT as per GPT 3.5, Gemini in its Pro version, Mistral Instruct, and I think excitedly for us, BG GPT by Insight. And here come the abridgment scenarios. So zero shot or just giving the model the original text and asking it to provide an abridged version. Then chunking, which is basically dividing the text into several parts and then asking the model to provide an abridged version of each part separately. And then one shot, as mentioned, when the model is provided not only with the text that needs to be abridged, but also with an example of another text here, The Little Match Girl, and an already abridged version of it. And then there is also the cross-lingual scenario, which comes in three sub-scenarios: direct, such as zero shot, and then a chain of thought scenario where more than one prompt is given, such as when the model is asked to first translate the text and then abridge it, and then vice versa, first abridge and then translate it. Starting with the automatic evaluation of the automatically generated texts, there are 10 separate metrics that have been employed. Rouge score, which is commonly used for summarization of text, and determines the overlap in terms of words between two texts. Then BERT score, which is often seen as an improved version of Rouge, in that it considers not words, but embeddings. So it focuses on meaning and can account for synonyms, let's say. And then the rest are readability-based atomic characteristics that have been traditionally used as a proxy for complexity of a text. Some are length-based, the total number of words per sentence, and the number of letters per word. Then there are a few vocabulary-based ones, type to token ratio, concreteness rating as per Brisbart's concreteness rated scale, and words outside of a given frequency list in the language. Then there is a syntax-related one, the ratio of content to function words, and finally, the percentage of anaphora denoting words, such as demonstrative pronouns or definite articles within a text. I will briefly explain what is used as gold standard in automatic evaluation. Here is where the professionally human-made abridged versions of the text come into play. So we take the range of values or ratios of the features, as explained, taken for the original text versus each professional abridged version. For example, we're taking the characteristic number of words. If it varies between 1.5 and 4 for the 4 professional abridged versions of the Little Duckling, then this range is taken as gold standard. And afterwards, we take a text that has been abridged by an LLM, for example, a ChatGPT generated abridgment of the little duckling, and we see that the ratio for number of words is 5. Then this goes outside the range that we've determined as gold standard. So this particular text is marked negatively for this particular feature. Further information about scoring a model based on this kind of evaluation: the percentage of examined characteristics that fall within the gold standard range. For instance, we have a total of 24 texts generated by ChatGPT for all scenarios that we're looking at, and they're evaluated for a total of 226 applicable characteristics. We see upon calculation that 93 of them fall within the gold standard range. Then we give the score of ChatGPT as 41% overall. Moving on to the human evaluation stage, which went afterwards. First of all, the 6 highest scoring large language model generated texts were determined based on the mentioned evaluation of characteristics. Where there were the same scores, it was a variety of generation scenarios that was sought. And a survey was composed in 3 versions for every one of the 3 languages. And each version consisted of 2 texts, one unique or only present in this version, and one that was also present in another version, in order to facilitate the calculation of agreement between the respondents. And minimum 1 participant per version and per language responded to the survey, and they were either native or fluent speakers of the language in question. A few words about the human evaluation protocol. It tested qualitative characteristics such as understandability, correctness, consistency, textual coherence, and aesthetic appeal. And there was a scale of 4 possible answers between no, through mostly no, mostly yes, and yes. And comments in free texts were also encouraged. Moving on to the results, first of all, those of automatic evaluation. Per language, we can see, as should be expected, that English did best. However, a little surprisingly, it was Bulgarian, the lower resource language, that followed, and not French, which performed significantly worse. Then by model, this is a little bit deceptive because Mistral was marked as closing highest in terms of percentage. However, quite a few of the experiments that were not based on English were discarded because of bad quality or complete inability to provide output. So important here also is that the performance of ChatGPT and Gemini is globally exactly the same. Then performance by generation scenario. The best rated scenarios were chunks, followed by Cross-lingual in its direct version. And then interestingly, the alternative text, the one that has not been published, actually performed better in a 0-shot scenario than the little duckling, which goes to say that either the text was not encountered by the models during training, or if it was, then this did not influence the results. Then by language and model, here we have only ChatGPT and Gemini because the other 2 models were really focused on one of the languages, such as BGGPT on Bulgarian. And Gemini performs better than ChatGPT only for Bulgarian, whilst ChatGPT performs better for English and French. By language and scenario, here we can see that there's really differing performance when it comes to the different scenarios and the different languages. For example, in particular, we can see that Bulgarian performs really well in the cross-lingual scenarios compared to the other languages, possibly due to a benefit from original text in another language, particularly English. And finally, by model and scenario, here it is difficult to generalize a trend. For instance, we can see again that ChatGPT and Gemini perform, although globally equally well, differently in relation to discrete abridgment scenarios. And finally, the results of human evaluation. They have been really dependent on the particular text and respondent, so they have been hard to generalize. So I will just mention the best scoring texts and some problems that have been noted or exact remarks. In English, the best scoring texts were the ChatGPT Cross-lingual direct and ChatGPT cross-lingual chain of thought with abridgment first, and they were rated perfectly, 100% for all categories. The Mistral model was associated with low correctness, and inconsistency of information was noted, such as, for instance, the little duckling being referred to as it or he in different parts of the text, or if the same event taking place more than once. For French, the highest rated model was Gemini Cross-lingual Direct. Problems with complexity, both in terms of vocabulary and grammar, were noted. And some comments included that the texts were not fluid or frustratingly weakly developed. And finally, Bulgarian, here Gemini Chunks rated highest. Some problems with correctness were noted, such as non-existent words or somehow non-suitable. And the text was often referred to as seemingly translated or close equivalent. Here, I don't think I have the time to dwell on these particular interesting instances in the Bulgarian text, but I will leave it here just for a second so you can see about the depressed duckling that turns into a beautiful pelican. And conclusions and future directions. The English texts understandably demonstrated the best quality, both in terms of automatic and human-based evaluation. ChatGPT and Gemini were models that are considered competitive and that did score competitively across all languages, including Bulgarian, which I think is a great thing to keep in mind. And there have been different weaknesses of the models in relation to different scenarios and even to different languages. Context length, it has been confirmed to still be a major limitation, as some texts were not possible to work with due to their length. And then possible ways to improve performance, because this study was meant to test the current or native performance of the models. Additional training, such as training on literary texts, then more elaborate prompt engineering. For instance, when it comes to the chunking scenario, there are references that point to possible improvement through merging of different outputs, again, using a large language model rather than just using them as R. And natural next steps in this framework would be the use of a variety of literary texts rather than just one text, which was the case now in order to determine the overall capabilities and trends. So texts of different genre, year of writing, or length can be used, for instance. And finally, something that's always a requirement would be to experiment with newer models, as by now, even the GPT 3.5 model is somewhat obsolete. Okay, this will be the end. Thank you very much, and I'll be happy to take questions.
Thank you for your very interactive presentation. Now we have the floor for questions.
Can you repeat what languages did you use for yourself?
Yes, sorry, should have said it more than once. So English, French, and Bulgarian.
So 3 of these languages are the so-called analytical languages. None of them is synthetic. And abridgment is more difficult to perform in synthetic languages in general. So I would commend that maybe in your future studies, you might want to include a synthetic language like German or even Russian for abridgment.
Yes, thank you very much. Really appreciate it. And I would be happy to add more languages. And on this topic, I will be having a presentation tomorrow that's also on abridgment, and that contains Russian. So hopefully there will be maybe some insights there that are relevant.
Other questions? Would you please return back the conclusions?
Sure.
We can have more context to give you.
I am not managing, sorry. Okay.
Thanks. Other questions? Can I get one question? How reliable is this automatic measures comparing to these human evaluations? What are your conclusions or recommendations? Which one we can use with big correlation with human evaluation?
I think the two types of evaluation have been very different, especially the automatic one being more quantitative and the human-based one more qualitative. However, the automatic one was performed first in order to select the best candidates for then the more qualitative and more detailed human evaluation, as it uses features that have been established as the most basic textual features that determine textual linguistic qualities or complexity. So I feel like the two work together at this point, like to first maybe filter the results and then learn more insight into the nature of the best scoring ones.
Thank you. Maybe a correlation, study a correlation between this automatic and human evaluation will be very interesting. And one more question.
Thank you. I was curious about something very specific about French, because if I understood well, there is in the Gemini generation part, you said that there are some problem in complexity, in vocabulary complexity. And I want to understand, how do you know that there are these problems? How do you define the complexity of some vocabulary or something like that? Thank you.
Yeah, thank you. So it is not about Gemini in particular, actually. It is in the survey, the human-based survey about the French language texts. It was a common occurrence to mark complexity a little bit lower than other metrics. And complexity has been divided in the survey into several categories, such as vocabulary, syntax, and a couple of others. The whole protocol can be found in the paper.
Okay, thank you. Think time for the next presentation. Thank you again. And I will give the floor to Sasha Petelinka.
Go to spaces.
Click on it. Just space. If you want to go back.
Okay. Good day, everyone. I will be presenting advanced sentiment analysis in Serbian literature, a zero and few shot learning approach using the Mistra model. That is done by me and my colleagues Milica Iković-Nešić, Mihajlo Škorić, Ranka Stanković, Bijana Ružević. We are all from University of Belgrade and we from the Society of Language and Resources, IRTEC. The goal is to assess whether we can use large language model instead of human annotators. Whether that offer consistent, efficient, and potentially less biased sentiment annotation in text. There is a rather large problem in less resource-intensive languages that we don't have enough annotated text, and that to get annotated text, sorry. And to get annotated text, we need to get a lot of people, a lot of resources to work that. And so we are wanting to see if we can use large language models. There has been few shots and zero shot good results in English. So we wanted to see if we can repeat that results in Serbian and other low resource languages. So that has specific challenges. And so I'm saying that we don't have enough, and yet I'm going to say that I have a data set which we have tested. That is something of catch-22 because to evaluate something, we need to have the data set. And we are using which existing data set, which we are taking 187 sentences from a Serope-Altec corpus, which has done annotation in several places by manual annotation, where we have gathered the concluded on scale for 0.5 to -2 to negative central gradation, from -1 to 1 for negative or objective, and 2 to 5 for positive sentiment. And then it has been calculated in annotation algorithm using the standard method, and there was percent and agreement 82.5% and other so we have done that. The Serope-Altec corpus is part of the distant reading for European literary history, and it is something that is available on the IRTEC site as a part of Aurora, under the supervision of Professor Svetlana Krstev. There is a lot of old novels there, and you can see some of them on a picture. I'm not going to talk much about that corpus because it has been said elsewhere. Here we see the balance of the corpus. Unfortunately, it could not be balanced because there was not enough female Serbian authors from that period, and there was not enough either in language to be properly balanced, but that hardly matters for this one. So this is the sentence length in words in distribution. If the sentence length is too short, we could have some trouble in some sentences to find out the context and sentiment. If it is too long, we have trouble going over the context window of a large language model, because especially when we are doing a few short prompts. So, but we from here see that we have mostly about 50 words, 50 to 100 words, the most is in that range. So that is rather nice corpus for this kind of research. So I'm going to say a few words about few shot and zero shot for those who are not familiar. Zero shot is when we can get the model to perform tasks just with instruction without any example. And few shot is when we give few examples to the model. That is very significant because we do not need a large corpora to train the model. We just give pre-train a model some instruction, and hopefully he does what we wanted him to do. This is how we have done, this is the methodology, the workflow. We start with the Serbian over sentences. The text is divided in sentences. Perhaps it would be better for chunking, but we didn't do that. Each sentence is divided into few short and zero short templates. Zero short templates by adding text become prompts. Prompts are fed to large language model. Large language model give us a response. That response is not always useful, so we will further process response into 0, -1, 0, 1, and 10, which -1 being negative, 0 objective or neutral, 1 positive, and 10 is a response which could be processed, so we mark it as error. When we do few shot, we also insert a few examples which were chosen outside of main dataset to insert into template, and then create prompt with the example, and the process is the same later. We have had two technical setups. That is mostly because we didn't have strong enough machine to do few shots in time. So for zero shot, we have used Hugging Face library transformers, standard mirror Mistral Bean struct, and we have limited outputs to approximately 7 to 11 tokens. That is enough to say a positive, negative, or neutral for ease of processing the responses. Few shots we couldn't do it in time because the prompts are much longer. With the other of examples, it took much more computational time to process that. So we have used the Llama CPP optimized library with quantized models. And we have used the Mistral Bean struct, which was quantized to 8-bit. For reason of wrong response, although that is, as I explained, has proven not very good solution. We have tested 5 templates. It was originally 6, but we couldn't fit the second few shot template into context window, so that was discontinued. First template is very simple and just standard prompt with role play as the expert. Second, we have added the chain of thought where we have explained in detail what the model needs to be done. Third, we have tried to increase the complexity by telling the model to act as the professor of Serbian literature. And third, we have combined simple with all caps to further signified important part and to role play as professor of Serbian literature. Few shot is very simple with examples do the limit of the prompt length. And here is, I'm going to just show one prompt, just one prompt example from simplest one. Here is the region Serbian that was used. And this is the English translation. It has proven experimentally when we tried on small numbers that using prompt in one language and text in another tended to really confuse model. So in English, we say as an experiment of sentiment analysis, that is a role, analyze following text in Serbian and determining sentiment, that is a task. The sentiment should be classified strictly as positive, negative, or objective. That is the output. No other response will be accepted. That is the constraint. Then it goes text, and where is text, the text will be inserted or sentence. And then it gives sentiment to proceed with sentiment. These were examples that we have used in a few short. For a negative example, it was the part of the funeral, and this English translation is not the best because I didn't know how to translate Kukavan. The Google Translate translated it as cowardly, but it's not that. It's a word when we use when we are mourning someone at the funeral, because he was such a good and faithful friend, and other accepted his eyes full of tears. That is words from the funeral, and no one will use cowardly in funeral. Second is very simple. Whoa, what a good woman, good as a good day. So, and third is a long explanation which does not have any objective. I surely didn't hit it 5 times, and half of the mortar fell to the side, another half, which is slightly large, turned out and crumbled to dust. That is an action which doesn't have any emotional significance. That was used as a prompt as a few shot. These are the results. The best results we gained with the template, with the simplest template, which is interesting. The second chain of thought with the role of expert has given rather bad results. The third, which we added Professor Serbian literature, has improved results, but still not as good as the simplest one. And the fourth has even further, but here the Professor of Serbian literature, rather than to improve that role, it has decreased. And few shot is somewhere second from the worst, but that maybe do different things, including that the model has been quantified and that the prompt is rather simple because a lot of place of the prompt is taken in explanation. Here we see the confusion matrix for the 0-shot template and for the few-shot template. We have the last column is errors. Here, their errors are completely lacking, but that is mostly because in Llama CPP the exits can be limited, so he didn't give any output that was. Even with that, it gave one error with severe limitation. And we see that in few-shot template, we have a really problem with determining negative sentiment. And in both templates, we see that we have problem between neutral and positive. A lot of neutral sentiment is translated as positive. So we are going to show some examples where it went wrong. First is where the annotators human annotators have marked it as negative, and our model has marked it as positive. This is all from the best model, from the first prompts. In even his brains began to throb, his heart tightens. Those three words uttered by Mladen seem to him as a prophecy spoke for a magnetic dream. So here I noticed that I think that annotators have used context from surrounding sentences, because when I see this isolated sentence, it's obvious that it has high emotional context, but whether it's positive or negative, I'm not sure. Second, the table was completely wet and the water dripped from his edges around the bit. It should be its edges. Around the bits of tobacco and cigarette ash, which I shook with a candlestick. This is some descriptive scene, and it's rather evocative, so I can see why the model had mistaken it, although it doesn't have emotional context. With rather evocative scene, he had mistaken it for a negative. And the last sentence is rather dramatically strange. Oh, if you only knew, dear friend, what delight is to shed a tear on a chest of faithful friend or a lover. And there is two additional problems with this. First is how it's ended with the punctuation marks are strange, and there is an apostrophe for shortening. So it is possible that such thing a reason why the model has marked it as error, giving completely nonsense result. So we are comparing this particular data set has been used in previous research. That is the reason why I used, because we could compare it. It is used for classification by multinomial naive Bayes. Using an additional sentiment lexicon, which was constructed for that. We had when it's used like that, it has a 65.7 accuracy, and when the adding bag of words approach with the lexicon-based sentiment features, it rises to 71.9. Mistral B-instruct gives accuracy with the best prompt with 68.2, which is a little lower than this, but it doesn't require to make a sentiment lexicon for this. It's much simpler setup to run, although it does take much more computational power. It needs better machine for this. But it is much simpler to set up because a lot of that is publicly available code. In conclusion, the superior results for this were achieved with rather simple prompt in literary text. And this is for literary texts, which are not something that model has been pre-trained extensively on. Quantized models tended to strip everything that was any benefits that are associated Mistral, and perhaps they should not be used for sparse languages, or we should test those for. I will speak of that more. All caps prompt were usable in reducing errors, but they also reduce accuracy drastically. Instructing LLM to detect sarcasm, that is notable in chain of thought, has induced over-detection of sarcasm. He tended to find sarcasm everywhere when you notice him. And he also literally professor inducing more complex role has improved with the chain of thought, but decreased with simple prompt. So the further research is to see if the problem is with few short prompts, or we can run on quantized Mistral zero-shot prompts, although I'm not sure how much benefit of that research, because by now Mistral is little obsolete. There are new language models which may give better performance. And perhaps since we have this, compare it to the fine-tuned XLR models like large multilingual Roberta, but this also requires fine-tuning. And of course, by now we have new models on which we can test, or we can start slowly inducing these results, begin producing syntactic corpora, which we can use for further training of the smaller models. I'm going to give my thanks to research was done under the support of the Science Fight in the Republic of Serbia. It's text embedding in Serbian language application, TEXLA. And here you have our emails if you want to contact us. So I'm opening for questions.
Thank you. And now question time.
Yeah, I have the following question regarding the so-called domain-specific knowledge. I mean, in order to be a professor of Serbian literature, you don't need only to know literature. You need to know history. You need to know something more I would call meta-knowledge. Do you think that instructing these models with this knowledge could improve their performance?
Well, actually, I think that it is more problem in the term professor of Serbian literature, because I have tried to mirror the English phrase, the Ivy League professor, which has proven to give a rather nice boost to the English prompts. But I'm not sure that professor of Serbian language is something that model completely understood. And I think that it is a little longer than that. I think that I have put the professor of Serbian literature which specialized in all Serbian texts. But it is probably not that model has not completely understood the role, although it did improve with the chain of thought. And the chain of thought would also could be improved if we use two prompts, but that would slow. We wanted to run something that can run on a local computer in a reasonable amount of time. not something which requires a specialized server or something like that. And not something that we could put working and then leave it for half a month. So chain of thought would probably be better improved if we put it, explain the sentiment in sentence and then add second prompt, now give the sentiment. Also, where it could be improved, for the further research is if we reduce instead of sentences on words, but we didn't have corpora for that, for evaluation.
Other questions?
Hello, I just wanted to ask you, were there any kind of, so the novels that you chose, the data set, were it from the same novel or from different novels, and were they on the same topic, or, because yes, the time is okay, I saw the period, but I was interested on the topic of the novels, if they were like maybe biographical or any kind of similarity between them. Thank you.
The only similarity between novels was the time period. That was the time of the cost action, and we have put novels which do not have what is the name, author. We just do not have copyright. And the sentences were randomly chosen and from everywhere, from a random sample from the larger corpora. There are a lot of novels there. There are some biographical. There is even science fiction, which is interesting. I didn't know that we have Serbian science fiction from the beginning of the century. There are novels which are novels, and so on. Any other questions?
Thank you first for the talk, and sorry if I missed it, but I was curious, why do you think that this zero shot was better than the few shot approach? Your explanation, why the simple method one? Thanks.
One reason is because we were limited with the context windows and the length of sentences. Some sentences went upon 250 words, and that's even more tokens. And then we expanded about 150 tokens for examples, which left only 100 tokens to explain. That is why we cut off chain of thought. So the context window in quantified Mistral is 512 tokens only.
Thank you.
Any other?
Questions? Okay. Thank you for the presentation again. And the next talk is from Yugoslav Karev. He will tell you what he's going to present.
Greetings, everyone. Today, I'm here to present you the paper that we wrote with Professor Kochev on the topic of generating phonetic embeddings for Bulgarian words with neural networks. As we all know, word embeddings are considered the cornerstone of modern NLP. Most embeddings model the semantics of words, or the meaning. And during my master's thesis, we asked ourselves, okay, can we have embeddings which model the way a word sounds? So if we would go in that direction, we would need a model that would work on phonemes instead of graphemes. The answer is yes, we can create such embeddings. We used a fairly straightforward transformer model, which is fed a word, the word Bulgarian word, which is split into syllables. then the model has to output the transcription of each syllable before the syllables are then connected back to a single word. And the main thing I want to highlight here is that we take a word, we split it in syllables, and we work with each syllables separately. And the output, again, is a set of syllables that we can connect together again in the right order. For the data, we extracted a few books from the popular Bulgarian site chitanka.info. 5 books were correlated, each in a separate text file. Then each book was transformed into sentences and then into words. For every word, we extracted the emphasis of the word. So because the emphasis changes the way syllables are transcribed then, we needed that as well. And for each word, we split it into syllables and manually generated the transcriptions that were fed into the model. So you can learn. And we see we have 6,000 words and transcriptions together to fit into the model. This is our first experiment that we did. Basically, we gathered 15 Bulgarian words, fed them into the model, and we saw, okay, what does the output of the model look like? If you look carefully, almost all the transcriptions are correct, except for the word czasownik, which means clock. There, the model got it wrong. I think if we take that transcription that is generated and put it in Bulgarian, we will get something like chayasnik or something like that, which of course means the model went wrong, at least on one word. However, this is only 15 words. We decided, okay, let's test it on something bigger. And how do we evaluate such a model? Well, as I said, we are working on syllables. So the first metric that we did was to take the Jacquard index and basically compare if the sets of syllables in the actual word is the same as the set of syllables in the predicted word. And we have 2 examples here with the word Bulgaria. All the syllables are correct, so the score for that word is 1. While for the word Rostov-Tyak, we have some differences, and the Jacquard score is 0.75. Over the whole testing data set, we got 99.751% match, which I think is really good for such a model. However, this metric has one drawback. We don't consider the ordering of the syllables themselves. We just check if the syllables are correct. So that's why we introduced the second metric, direct comparison, which basically goes through syllable, and check if the current syllable is in the right place compared to the actual word that we should predict. Here we can see again the word Bulgaria, Rostov-Tyak, and another word Primeren, where we see that if we have the same syllables but in different places, this metric will yield a lower score. And again, on the test dataset, we get 99.285% match, meaning that there's 0.2% of words that have the correct syllables, but in the incorrect places, which was interesting to me at least. However, this is just a transformer model. What can we do with it? Well, we can take the embeddings that are generated by the encoder, and we can use them to perform some task and see how they measure up. Again, it's very important to mention we have multiple embeddings for a single word. So if we have a word from 3 syllables, we'll have 3 sets of embeddings. The first task that we try to accomplish with those embeddings is the paronym detection. 2 words are paronyms if they are close in sound but different in meaning. As an example, in Bulgarian, the word statistic and statistic are such paronyms because they sound really similar, but of course their meaning is completely different. And we ask ourselves, okay, using those embeddings, can we create a model that predicts if 2 words are paronyms or not? Of course, when dealing with embeddings, cosine similarity is an important metric used everywhere. We compare each vectors, we compare the length of the words in the given formula, and we get a metric, how close do the 2 words sound. From there, we created a small data set with 185 words, 92 paronyms and 92 non-paronyms. We split the data set and we created a simple logistic regression classifier to classify if 2 pairs of words are paronyms or not. And this is in the first column, you can see the results using the accuracy, precision, recall F1 metric. And on the right, we trained the same classifier, but this time with the fast text embeddings. And as we can see on the accuracy, we have similar results to fast text. Precision is a bit lower for our phonetic embeddings. However, the recall is higher, and the F1 score is a bit higher for our embeddings. So at least for the paronym detection task, our phonetic embeddings perform slightly better than the FastTech ones. The second big task that we try to accomplish using those phonetic embeddings is the language of origin detection. Considering that we now have embeddings which model how a word sounds, we can try to determine if a word is from Bulgarian or not from Bulgarian from any other language, which is used successfully in a algorithm to detect loan words in Bulgarian sentences. For there, we created an RNN classifier, which takes a word, splits it into syllables, gets the embeddings, and then it classifies it based on the language of origin. 3 linear layers in the model, each syllable is passed through the model. We keep the hidden state and we pass it for the next syllable. At the end of the word, we get the top 5 most probable languages of origin for the given word. The data set we collected from 2 loanword dictionaries. We have 5,000 pairs of words. And from there, we created 3 sets of data, depending on how many non-loanwords or Bulgarian words we put into the data set. We have 5,000 Bulgarian words, 13,000 and 30,000 Bulgarian words, along with the 5,000 loan words. So we have those 3 data sets to model basically how much loan words we put. And so from there, we have 3 models, and we compare those 3 models with BGPT, ChatGPT 4o, and again, same model, but with the FastText embeddings. Here we can see that the metrics rise the more Bulgarian words we have in the data set. However, this just means that the classifier just predicts every word as Bulgarian, and of course, it will perform better the more Bulgarian words they are. What was curious to me was that our phoneme loanword embeddings and classifiers performs comparatively to BGPT, which is a much larger model, and are also not that far away from ChatGPT, which of course is an even bigger model. Compared to FastText, we are a bit behind, unlike the paronym detection, but I think there is much room for improvement in our model. Again, yeah, basically we don't take some things into account. The main one being is the difference between similarly sounding syllables. For example, ma and na should be way similar than ma and po. However, the embeddings prove that they do not exhibit this property. So this is something we could probably work on. And of course, if you have a word with 2 syllables and you have another word with those 2 syllables and the second one repeated again, distance is not consistent. So in some cases, when you work on word level, the differences are not that consistent. And of course, this model was developed only for Bulgarian currently. However, it is possible to extend it to other languages. And as a conclusion, yeah, basically we built embeddings which model how a word sounds, which are successfully used in paronym detection and language of origin detection. Thank you.
Questions?
Just a thought. So embeddings gives kind of an association with a representation of meaning. And I'm thinking about some theories that claim that there is a link between the sounds within a word or how easily it's pronounced and what it means. Could something be done in this direction to test such a theory?
Could be. During I think the training process for the embeddings, I think we could enhance the embeddings with the meaning. For example, just do a bag of words training or just enhance the MoE in FastText or something else to incorporate the meaning of the word, not only the sound. So I think, yeah, that could be an interesting theory to work on.
How big did you use for transformers? How many transformers layers did you use?
3 layers. On the encoder, 3 on the decoders. The embedding size is 512.
Do you think that increasing the size would help?
It could help, however, that would require a bit more compute resources that I didn't have at the time. So that's why I limited to 3 layers each. I see in the back there are some questions.
I just wanted to know, you mentioned that you took the emphasis information from a database.
Yeah.
Which one was that?
From the site deutschtanke.info, they have the database of the emphasis.
Okay.
And yeah, it's described in the paper itself a little bit more.
Thank you.
Okay. If there are no more questions, thank you.
My pleasure to announce lunchtime. The lunch. Hello? The lunch will be served outside. Stay tuned, stay here. Don't go over.
Презент науки, допускате.
Може и в презент. Както решиш.
Презент. Виждам много ясно часовника. Най-вече.
Thanks.
Ето това ли? Добре, затварям. Eject, не знам даже откъде. Беше за къде eject, нали така? Добре. Е готово.
На имейла трябва да е пратила поем на Толи.
Ами ето вече.
Ето. It's here. It's here. Това мисля, че за следващата сесия. За 3.
Сесията. The first. I'm the first. Okay, нас го купихме.
От него 1000 пъти. Преди се твори. Момент. Downloads. Що ми беше? Оставам да оставам така, другите 1000 неща ги затварям.
Трябва да има една малка флашка.
Ето я.
Значи, климата за следове да ги има, нали? Можете да имаш Андрея. Значи, трябва да получи още много.
Значи, мисля, че точно тя беше, ето на от флашката, CLI трябва да се казва. CLI, клип. Клип. Само да видим обаче кой е този пейпер, четвърта сесия, може би да го прекръстим. То само се отваря, да. И сега тя също ще ни даде. Що ни хареса. Аз мисля, че правилно го сложих, не знам дали е.
Си камерата ще да се чука.
Това трябва да е дошло. Андрея. Сега ще дойде последна, аз съм е писала да правиш.
Това нещо не се хареса. До колко бяхме?
1:45, обаче ще има включване онлайн, така че ако може 10 минути по-рано да сте тук. Да. Да. Не просто, защото ще се включи човек онлайн, да имаме готовност. Да. Да, тя е в същия файл, но вие сте я даунлоднали сигурно, защото аз апдейтвам самия файл. И тя е, да, един момент, и сега пак ще върти.
Това само да видим коя сесия. Четвърта сесия. Your last session, I suppose. Okay. And Verginica.
Okay, so you
okay.
Shall we number them so that you know?
Okay, so that's enough. I don't have to see it.
No.
Everything is set.
That's да, идеално, благодаря. Да, няма проблем. Третото липсва на... Качих 1, 2 и 3 за четвъртата сесия, липсва е това последното.
Да, казах, че тя пътува.
Добре.
Би трябвало да си я прати по-рано, сега ако не е пратили, ще я
Добре, 3 ги номерирам. Това е...
Hello.
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 I think we can all hear you in the room.
You cannot hear me, or?
No, we can.
We can, okay.
Yeah, so
Great.
I think everything's all right.
Shall I try sharing my screen to see that that works too?
Yes, please.
And let me go to... How does that look?
Yes. Yes, everything is okay.
And it moves when I move it?
Yes, it does. Yes.
Perfect.
How Joachim?
Hello,
Nice to
hello.
see you. Hi.
Hi.
I came just to say hello.
Okay,
Wish you a great success.
thank you.
So I don't doubt, as I mentioned, Petya is going to present you.
Right,
in a while,
yes.
but I think we still have 10 minutes or something like that. So
Okay, yes, sure. This was just for checking that the connection
yes.
works and everything. So
Yes,
I will take a break and be back in 10 minutes or so.
okay.
Good. I will stay connected though. I'll just mute and switch off my camera.
Okay. Okay. See you in a while.
See you. Bye-bye.
Bye.
Yes. Yes. It was supposed to be, I was not very nice. Right. Yes, there is five. Number 5. There is about 5 million. Yes. Not in. Yes. Because that's like a passing on the strong. But there is probably 5. It comes. There is it's also more precise. Yes. Yes, there was about 4 buses. Next, that's about the same difference from they talk about just that's I don't know what it is so much we really fast because most of aspects of but there was some no, there's just message it wasn't still no, the next year that we completed that it's not next time. When they reach internally speak that word. While instead of getting third with graders, there is significantly different. I'm speaking
Hey, hi.
Hello, Petra.
Hi, Joachim. So I have the honor to present you to the audience, and everybody is very sorry that you are not here face to face with us. But we know that, yeah, it was not possible this time. Maybe next time.
Thank you.
Okay, so let's start with the presentation. First, I'd like to say some of the facts of Joachim's biography, and then also what I think about him. Joachim Nivra is a professor of computational linguistics at Uppsala University and also he's senior researcher at Research Institute of Sweden. He holds a PhD in general linguistics from the University of Gothenburg and PhD in computer science from Växjö University. So he's interested in data-driven methods in natural language processing, especially morphosyntax and syntax, also semantics. It should be noted that he's one of the main developers of the transition-based approach in parsing, especially syntactic dependency parsing. And the MALC parser that was the result of this is very much used even now. I mean, in the era of large language models. Lately, one of the really major initiatives is the Universal Dependencies Project. Yesterday at the tutorial, I didn't have the time to say more, but I told you that today you will listen more about this. At the moment, there are, I think, 180 language, 200 and something, 3 banks and 160 languages. I mean, this initiative, as you see, it is 10-year-old already, very mature, and a big one. I think it is the state of the art at the moment for dependency resources and dependency parsing as well. He worked in Google, and also he was president of the Association for Computational Linguistics in 2017. And so I can continue and continue, but I prefer to stop and to say that to me, Joachim and his team are also one of the best typologists. They developed into typologists with so many languages. And I remember when I met him years ago in one of the editions of the workshop for 3 banks and linguistic theories that started early 2000 year. Then he had a paper called What Kind of Trees Can Grow in Swedish Soil. So I think that we saw many nice trees can grow there and also in other soils, but we also saw that during these years that also great researchers can grow in this Swedish soil. One of them is presenting now. So Joachim, you have the floor.
Thank you. Thank you so much, Petya, for that very kind introduction. I'm really delighted to be here talking to you about universal dependencies. My only regret is that I am also sorry that I couldn't be there in person, but unfortunately it wasn't possible this time. So hopefully some other time. So let's start from the beginning. So what is universal dependencies? Well, Petya already mentioned a little bit about it in our introduction, but if you go to the Universal Dependencies website, you can learn that Universal Dependencies, or UD for short, is a project developing cross-linguistically consistent tree bank annotation for many languages with the goal of facilitating multilingual parser development, cross-lingual learning, and parsing research from a language typology perspective. And I think this is a fairly accurate description of the project at the time when it started, but it has been 10 years and it has evolved in a number of ways. So I think it's fair to say that today UD is not only a project, it is an annotation scheme, a data repository, and arguably a kind of research community. And in this presentation, I want to touch on each of these 3 aspects in turn, and give my sort of reflections on how things have developed over these 10 years. But before we go into that, I cannot resist the temptation to take a little stroll down memory lane and tell you the story of how it all started. And I think different people who are involved in the initiative would maybe tell this story in different ways. But for me, this all started in 2006 with the first CONL shared task on multilingual dependency parsing. And I want to take this opportunity to acknowledge the huge debt that the community owed to these 4 people, the organizers of the first shared task, who managed to pull together at the time dependency tree bank for no less than 13 different languages, which was an amazing achievement at the time. And not only that, they also came up with this standardized data format called the CONL X format for representing these that became a de facto standard for years and years. Now, at about the same time, in California, our colleagues, in particular Marie de Manef and Chris Manning, released the first version of the Stanford dependencies, which at the time was not really an annotation scheme. It was rather something like a front end to a syntactic parser, because in those days, at least for English, most of the parsers were based on constituency, not dependency. But people who developed NLP applications often found it more useful to have dependency representation. So they came up with this scheme as a way of taking the output of a constituency parser and converting it to dependencies. Now, a year later, my colleague Ryan McDonald and I wanted to do an error analysis based on the CONL shared task. We wanted to compare parsers across languages. And one of the things we wanted to do was to see how well they dealt with different types of linguistic constructions. So we tried to compare linguistic structures across languages. And it turned out to be extremely difficult because even though there was a standardized data format, at that point in time, every tree bank had pretty much its own annotation guidelines. In the end, we managed to, after reading all the guidelines carefully, come up with some very broad categories. You can see part of speech categories in this slide if you can read it. But it was very, and that we could map to, but it was quite fuzzy and sort of imprecise. Now, a few years later, my colleague Daniel Zeman at Charles University in Prague approached this problem in a more principled way and came up with the interlingua, the interset interlingua, which, as you can see in this slide, is meant to be a nearly universal set of features that can be used to map between different part-of-speech tagging systems. Now, a few years later, Google released their own version of this, the Google Universal Part-of-Speech Tag, which was actually based or started with the mapping that Ryan and I came up with for the error analysis in 2007. Now, meanwhile, in Prague, Dan and his colleagues had taken this one step further and started harmonizing not only part-of-speech tags, but also the dependency annotation, essentially by converting many tree banks to a version of the Prague dependency tree bank annotation scheme. Now, the year after, again in collaboration with Ryan and others at Google, I was involved in an initiative to release what we called the Universal Dependency Tree Banks, not to be confused with UD itself. And we were very happy to be awarded an ACL Test of Time award last year for this paper, where we tried to propose a sort of a common standard based on the Google Universal Part-of-Speech Tags and a version of Stanford dependencies. Now, this immediately prompted a reaction from our colleagues in Stanford, who liked the idea of a universal scheme, but didn't like some of our decisions. So they came up with an alternative proposal and eventually even hijacked me into becoming an author of this paper, contradicting myself, essentially. And this was the point at which we said, enough is enough. Let's stop multiplying these standards that are almost the same but slightly different. Let's all get together and agree on a single standard. So we had this kickoff meeting in Gothenburg in 2014, and then released the first version of the Universal Dependencies Guidelines in 2014, which then was based on revised and extended versions of the Universal Stanford dependencies, the Google Universal Part-of-Speech tags, and the interset system of morphological features. Now, in January the following years, we had the first release of tree banks for 10 languages, so fairly modest at the start. In 2016, we released the second version of the guidelines, where we tried to fix some of the most obvious mistakes in the first version. And then 2017 turned out to be a very productive year for universal dependencies. So the slide I'm showing here is from the closing session of the first UD workshop, which is a workshop series, that has been held annually ever since. We also had a tutorial at EACL in Valencia, and more importantly, we organized the first of a new series of Connell shared tasks on multilingual dependency parsing, very much in the same spirit as the original shared task from 2006 that it all started with, but this time with data sets that were standardized not only with respect to the data format, but also with respect to the annotation scheme, therefore hopefully allowing more meaningful comparisons across languages. Now, here is an illustration by my colleague Philip Ginter trying to show the impact that these shared tasks had on parsing for many languages. I realize that this is too small to read, but the idea is that on the x-axis, you have the amount of data that is available for a language. On the y-axis, you have the best achieved parsing accuracy for that language, and every arrow here is a language. So what you can see is essentially that all languages improved on one of these dimensions, and the majority on both of them. In 2020, we reached the important milestone of having more than 100 languages in UD, and we also saw the first of a second series of shared tasks, this time on parsing into enhanced dependencies, which is this richer version of the syntactic annotation that exists for a subset of languages in UD. And finally, in 2022, we introduced a new policy for making updates to the annotation scheme without necessarily changing the entire version through a system that we call amendments and clarifications. All right, so after this sort of personal history of UD, if you like, I want to talk first about the UD as an annotation scheme, which obviously is very central because the whole effort is about trying to achieve cross-linguistically consistent morphosyntactic annotation so that we can make the kind of meaningful comparisons across languages that we couldn't do in 2006 or 2007, and therefore thereby, I should say, support multilingual research in NLP and linguistics. We decided to build the system on common usage and existing de facto standards at the time, and I think sort of the development has shown that this was a wise decision, because I doubt that adoption would have been as wide as it has been if we had not made this choice. Another point that is perhaps not emphasized as much as it should be is the fact that UD was never meant to replace all other annotation schemes. It was meant to be a complement to language-specific schemes, because the goal of making cross-linguistic comparisons by necessity implies that you have to abstract over some of the finer details of individual languages. So if you're primarily interested in all these details of a single language, then UD may not be the best choice for annotation. But as soon as you want to make comparisons to other languages, especially languages that are maybe typologically different, then hopefully UD should be helpful. Now, the basic philosophy of UD has often been summed up in this slogan: maximize parallelism between languages, but don't overdo it. And what we mean by that is that we want to bring out things that are similar and parallel in languages and not obscure them by having different annotation categories or different guidelines for their annotations. But of course, we shouldn't go too far. We shouldn't make languages look parallel when they in fact aren't. So the idea is to aim for something like a universal taxonomy with language-specific elaboration. Now, a few basic design principles. One was the choice to base UD on a dependency-based view of syntax. And this was, to a large extent, an opportunistic choice. Dependency was, at the time when we started, already widely used in practical NLP systems, and for all languages except possibly English was sort of the dominant paradigm. It was also available in tree banks for a fairly large number of languages, so we had hopes that they could relatively easily be converted to the new standard. The second important design principle is the adoption of a lexicalist view, which in this context essentially means that we take the basic annotation units to be words. Words have morphological structure and morphological properties, and those should be captured in a morphological annotation layer. Words also enter into syntactic relations, and those should be captured in a syntactic annotation layer. But we assume a fairly sort of strict division between these two layers. But it's important to also note that when I talk about words here, I mean something like syntactic words or morphosyntactic words, not orthographic words or phonological words. And this means that we have to take care when segmenting sentences into words in a language. So before I move on to the actual sort of annotation, I want to say a few words about this problem of word segmentation, which has turned out to be one of the most challenging of the whole endeavor. That is to come up with good criteria for segmenting sentences into words across typologically different languages. And we still don't have a completely satisfactory solution to this, but we do provide sort of some rules of thumb to help people make reasonable decisions here. So on the one hand, we say that a word should always have a single part of speech tag. So if you look at some segment and say, that's an article, but there's also a preposition in there, then you're probably looking at something that is the fusion of two words and that maybe should be segmented into two words for the purpose of annotation. On the other hand, every word should have a real syntactic relation to some other word. So if all you can say about a segment is that it is an inflection of some stem, then it's probably not a word, but an affix. So but in order to make this more transparent, UD offers the possibility to represent segmentation at two levels: a basic orthographic segmentation level, which for many but not all languages can be achieved essentially by relying on white space and punctuation. But then in addition to that, this level of syntactic words, which is a more linguistically informed notion that we use for annotation. So just to give you a couple of examples of what this could mean in practice, in French, there is a token au, which linguistically speaking is a fusion of the preposition a and the definite article, the plural definite article le. And for the purpose of annotation, we can segment that into two words so that we can assign them different functions. Similarly, in Spanish, dámelo is written as a single orthographic token, but linguistically it's a verb and two pronouns, meaning give it to me or give me it, literally. And again, to get a full syntactic analysis, we may want to segment them into multiple words. If we move to a language like Hebrew, it gets even more complex because Hebrew still uses spaces between words, but it tends to put more linguistic material between the spaces than in most European languages. So if we read this token on the left, it means something like "and that in the sun." So it's actually, linguistically speaking, a conjunction, a pronoun, a preposition, an article, and then a noun. And again, for the purpose of annotation in the Hebrew tree bank, this is segmented into 5 words. And of course, there are languages that don't use spaces at all in their writing system, like Japanese. So this string of characters meaning Osaka Convention Center also needs to be segmented into words before we can start annotation. Now, so moving on then to the morphological annotation layer, assuming that we have sort of a word segmentation, I'm going to use a French example here for illustration. Le chat chasse les chiens. The cat chases the dogs. We can assign to each word a lemma representing the base form. Now, lemmas are language specific, so UD doesn't have a lot to say about how they should be, what they should look like. But then we want to assign also to each word a part of speech tag representing its grammatical class. And this is where we use this inventory of part of speech tag that is a revised and extended version of the Google Universal Part of Speech tag set, which currently contains 17 categories. They can be broadly divided into open classes like adjective, adverbs, nouns, and verbs, and a few others, and closed class like adpositions, which generalizes over prepositions and postpositions, conjunctions, coordinating and subordinating, auxiliaries, pronouns, and so on. And then a few special categories for things like punctuation and symbols. And the X category is sort of is a category that can be used if you really have no idea what a word is. Now, it's important to note that this is a fixed inventory. So you cannot invent new part of speech tags for a specific language, but all languages don't have to use all the categories. So if a language, for example, does not have a grammaticalized distinction between common nouns and proper nouns, they don't need to use both the noun tag and the proper noun tag. They can use simply the noun tag in that case. Now, these part of speech tags provide you with what for many languages is a very coarse-grained classification, especially if it's a morphologically rich language. So in addition to this, we also have features that represent lexical or grammatical properties, either of a lemma or of a particular inflected form. So in the case of French, nouns would typically have features for gender and number, and verbs would have, in addition, features for mood, tense, and so on. Now, here we also have an inventory of universal features, and for each of these features, there is also an inventory of possible values. But unlike the part of speech tag set, this is not a fixed inventory, because here we realize that as new languages get added to UD, the need for new features or for new values of existing features may appear. So here it's you can always sort of add new features or values. And if they turn out to be useful for more than one language, they get incorporated into the inventory of universal features and values. All right, so far about the morphological layer. Let me turn next to the syntactic layer, which is the second layer of the annotation. And I'm going to use an English example for this section. The cat could have chased all the dogs down the street. And I already said that UD, as the name implies, assumes a type of dependency representation of syntax. But it is a rather special version of dependency, which actually not all dependency grammarians are happy about. So the basic idea is that we start by connecting content words by syntactic relations. So in a sentence like this, the sort of the most central word is the main verb chased, which has three direct dependents. There is a nominal subject headed by the word cat, there is a direct object headed by the word dogs, and there is an oblique or locative modifier headed by the word street. Function words are then essentially attached to the content word that they modify. So determiners go with nouns, auxiliaries go with verbs, and even a preposition like down in this example is essentially treated as a case marker on the noun rather than as the head of a prepositional phrase, which is perhaps the most controversial part of UD syntax. Now, if you want to include punctuation as well, we have guidelines for that too, but I won't go into them here. But I want to spend just one more minute on explaining and motivating why we draw the syntactic representations in this way. And I'm using here again an English example. The dog was chased by the cat with a direct translation into Swedish and Czech. And the point is, coming back to this slogan of making languages parallel, is that if we focus on direct relations between, in this case, verbs and nouns, then we actually have a parallel syntactic structure for these three sentences in three different languages. And I think most people would agree that there is a parallelism here. There is a passive predicate, there is a nominal subject, and there is an oblique agent modifier expressing the agent of the action. What differs between these languages is the way that different grammatical categories are encoded in the language. So, for example, definiteness is encoded in English with a separate function word, the article the. In Swedish, it is an inflectional category on the noun, so there is an affix on the noun marking definiteness. And in Czech, there is nothing because definiteness is not a grammaticalized category in Czech. Similarly, the passive predicate is a periphrastic construction in English. It is, again, a morphological inflection in Swedish. At least that's one of the options that exist in Swedish. And in Czech, it's arguably a combination of the two because there is an auxiliary, but the particular participle form is unique to the passive. And finally, the agent phrase or the oblique modifier is encoded with a preposition in Swedish and English, but with the instrumental case, so a morphological case inflection in Czech. All right. So in order to classify these syntactic relations, we have also have a taxonomy of currently 37 universal relations. And this taxonomy is organized by two main principles. The first is the assumption that in all languages, we expect to find three major types of structures. Clauses, which are organized around a predicate and its dependents. Predicate are often verbs, but they don't have to be. Secondly, nominals, which are nominal expressions whose perhaps primary use in language is to refer to entities. And then modifier words like adjectives and adverbs that can modify either nominals or predicates or clauses. The second principle is a distinction between, and this is at the clause level for dependents of predicates, between core arguments, essentially subjects and objects on the one hand, and all other dependents on the other. We do allow language-specific subtypes, so there is some flexibility here, although they are optional. But the idea is that if you want to introduce a special relation for a particular distinction in a language, it always has to be a subtype of a universal relation, so that for the purposes of cross-linguistic comparison, you can back off to the universal relation. I should say, and I've sort of mentioned this already, that the syntactic annotation comes in two versions, the so-called basic and the enhanced dependencies. Basic dependencies are the ones that I've been showing you so far. They always form a simple tree, although it can be a non-projective tree. The enhanced dependencies have additional dependencies to capture relations that are only implicit in the basic relations, like control relations or propagations over coordinations. And in a few limited cases, they even can have empty nodes in cases of ellipses like gapping. Now, the enhanced representations, as I mentioned, are only available so far for a subset of the UD languages, and I won't go into them further now. So here is a table showing the 37 different relations, and I won't have time to go through this in detail, but let me just sort of explain to you how this table is organized according to the two main principles that I just mentioned. So in the first row, we have core arguments or core dependents of predicates at the clause level. In the second row, we have non-core dependents of predicates, and in the third row, we have dependents of nominals. And then we have four different columns for different forms that these dependents can take. So they can be nominals, they can be clauses, and those are the only two options for core arguments. They can be modifier words like adjectives or adverbs, or they can be function words, which as I already explained, get a special treatment in UD. In the bottom row, we have everything else that is needed to do full tree bank annotation. So special relations for coordination, for headless constructions, which we recognize even though it's a dependency-based view of syntax, loose, connected, like parataxis and so on, and a small set of special relations that are needed for things like disfluencies in speech or typographic errors in writing, or the orphan relation, which is for cases of ellipses. All right, so that sort of concludes the tour of the annotation scheme. So I now want to move to the second aspect that I mentioned in the beginning, namely UD as a data repository. So this is a repository of tree banks or morphosyntactically annotated corpora, which has grown at a rate that none of us could imagine when we started the project. And we are extremely grateful for all the contributions that we've got. So in the latest version released in May this year, we have data sets for 161 languages representing over 30 language families and nearly 300 tree banks, because many languages by now have more than one tree bank. This is altogether about 2 million sentences or 32 million words, which of course is not a lot if you compare to the enormous data sets that are used to train large language models, but we have to remember that this is linguistically annotated data sets. And this is the most important point, this has been possible only thanks to the amazing contributions from over 600 researchers around the world who have found it worth spending time and effort at contributing to this repository, for which we are immensely grateful. Now, just to give you a little glimpse of what languages are actually in here. So in terms of language families, it's inevitable that it's skewed towards Indo-European, but it has become considerably more balanced over time. So in the first release, we had 80% Indo-European languages. In the latest release, we have 46%. We hope that, and we conceive that by now, at least a few other language families are starting to have good representations. Similarly, if we peek inside the Indo-European family, we see certain branches dominating, in particular Slavic, Germanic, Romance. But again, it has become more balanced over time, and we now see representation also for many other branches. So we hope that this will continue. Now, one thing that you cannot see from a diagram like this is the amount of data that is available in each tree bank or for each language. And that is something where the picture is maybe not quite as rosy, because Here is a diagram showing the sizes of all the tree banks on a logarithmic scale. And what we can see is that, yes, there are a few really big ones that contain more than 1 million words, but the overwhelming majority of tree banks are much smaller. And in fact, the median size in the latest release is about 23,000 words. Now, these many small tree banks can still be extremely valuable. In many cases, they are the first existing annotated corpus for a language. But of course, for some of the original use cases of UD, like training and evaluating parsers, they may be less useful. So one of the most important challenges that UD faces going forward is to make sure that we do not only get data for more languages, which is always welcome, but that we can also get more data for the languages that already exist to make these resources even more useful. Now, I want to end by saying a few words about what I called the UD community at the beginning. The UD community is very much a self-organizing system, but at the center you have the Universal Guidelines Group, which is this group of 17 people, the majority of whom were also founders of the project and who are responsible for maintaining the Universal Guidelines, but also for data validation and data releases. And here I want to again acknowledge a huge debt that we all know to Daniel Zeman, my colleague at Charles University, who puts in an enormous effort at making sure that the whole system with validation and data releases actually works twice a year. Now, in addition to the Universal Guidelines Group, we have the equally important and much larger group of tree bank developers. These are the 600 plus people that I already mentioned, and who are all responsible for their own data sets, but also importantly for the language-specific documentation that needs to complement the universal documentation. But it doesn't end there. We also have another growing group of people, which are the tree bank users. So researchers and maybe developers that make use of these resources for research or for technical development. And until recently, at least I had a much vaguer idea of what goes on in this larger community. So as we were approaching the 10-year anniversary, I decided that I wanted to learn more about this. So I made a literature survey with the help of Google Scholar. So everything has to be taken with a pinch of salt. But still, I searched for papers that contain the exact phrase universal dependencies, which turned out to be a lot more precise than I had thought. And this, first of all, gave me some publication statistics. And of course, we know the exact numbers cannot be trusted, but I do think the overall trends can be trusted. So we've seen sort of a steady increase in the number of papers that refer to universal dependencies each year. And now we're probably starting to see the beginning of a plateau or maybe even decline, who knows. But more interestingly, what are all these papers about? So I couldn't read them all, but I went through a sample of 20% from each year and looked at least the title and abstract and tried to classify them into broad categories of research. And I won't have time to go through this in detail, but I just want to point out that if we look at the bottom three categories, the blue, green, and yellow, which are papers about universal guidelines, UD or other, papers about language-specific guidelines or tree banks, and papers about morphosyntactic and semantic parsing. You could say that this is sort of the cases that UD was originally designed for. And we see that for most of these 10 years, that have been the dominant type of research, in particular parsing, boosted by the various shared tasks that were organized. But we see that in recent years, we also see increasing representation of, first of all, downstream NLP tasks, which is to some extent maybe surprising given the recent developments in the field where people do not necessarily use parsers to develop downstream systems anymore, but also, interestingly, linguistic research, in particular, I would say typological research, where people make use of these resources to study languages. And then this small but interesting and apparently growing category of making use of linguistic resources to make sense of what NLP models, in particular large language models, actually learn about language. So we think it's, on the one hand, we are aware that the field of NLP has been sort of, to some extent, been moving away, or maybe to a large extent, been moving away from the use of linguistically annotated resources. But we find it reassuring that it seems that people find other interesting uses of these resources. So it's time to sum up. I think on the positive side, we have been very fortunate to see an amazing growth in terms of contributors and tree banks. And I think this survey has shown that data sets are, or at least have been, widely used for research in NLP and linguistics. But we should also acknowledge that there are challenges. Data sets are uneven in terms of quality and quantity. I focused on the quantity in this presentation, but anyone who has been actively working with the resources are aware that the quality or consistency of annotation also varies a bit between different data sets. We think that the annotation scheme, and perhaps particularly the documentation, the guidelines, can be improved to better support people's efforts to annotate different languages. And it's also clear that relevance to the research community cannot be taken for granted. I will end here so that we have at least a few minutes for questions. And I want to end the way I always end when giving a presentation on UD, by thanking all the UD contributors, without whom UD literally would not exist. Thank you.
Thank you, Joachim, for the nice talk. Yeah, because there are some minutes, I just rush with the invitation for questions from the audience. Meanwhile, I can ask a question also, because yesterday I tried to have a tutorial on tree banks in the era of large language models. And I just made a review of different papers, how they integrate syntax in the models. Just in brief, can you tell us what do you think about the role of these tree banks as syntactic knowledge bases for the large language models?
Yeah, I mean, it's that's a highly relevant but also very hard question. I mean, I think we have to be honest and fair and say that for the moment, they don't seem to play any real role in the development of the models. And I think it's, for the moment, it's unlikely that we will see their use to actually improve the performance of the model. Maybe this could change in the future. We've seen similar developments before. When we had the first so-called statistical revolution in NLP, people were saying for a while that all we need is data and statistics. And then people discovered that after a while, things started to plateau. And then it was only by making use of linguistic knowledge that you could improve further. I mean, I do think that the change has been more drastic this time, so it's unclear whether we will see a similar development, but it could happen. But in the meantime, I think sort of making use of these resources for evaluation and for understanding is still something that is highly relevant. We all know that large language models have very good performance on sort of large languages, but we are aware that there is a variation on sort of, I mean, not even extreme low resource languages, but even languages that just have not as much resources as the biggest one. And making use of linguistically annotated data to get a more precise view of where the shortcomings are, I think is clearly a very important effort. And then, I mean, the other thing about interpretability and understanding. So I would say that for the moment, at least, those are the main uses I see, but it could change. So what were your ideas in the tutorial? I'm curious.
Yeah, I will send you to see what papers I found for integrating syntax. Okay, just if there is any brief question, or maybe later on, I suppose that they can contact you, the audience.
Oh yes, absolutely. Absolutely.
Thank you.
And
So,
if
yeah.
anyone would like the slides, think I've already shared them with the organizers, so
Yeah,
you can
yeah, that would
distribute
be
them.
great, really. Yeah. Okay, then I don't see any raising hands. So thank you once more for the nice talk, and hope to
Thank
see you
you
next
very much.
time.
Thank you very
Joachim.
much. I hope you had a continued successful conference. Thank you.
I'll use the time while we are switching between presentations to start introducing the next session. My name is Milena Dobreva, and it's my pleasure to chair a session which actually will continue the topic of universal dependencies in many ways. We just saw a slide with a very long list of contributors to the area of universal dependencies, and the names were so small I couldn't check if our presenters are listed there. So maybe this list will grow a little bit longer in the future when their work is more visible. In this session, we will hear 3 papers coming from authors with different backgrounds. One paper will be presented by a very nice lady who has a computer science background, and 2 papers will be presented by linguists. The papers are looking at universal dependencies in 3 different languages, Albanian, Romanian, and Bulgarian. Maybe those of you who are familiar with the density of existing resources would know that Albania still is not very visible with resources in the international set of these 150 different languages which are represented. But we have some from dedicated to the Bulgarian and Romanian languages. So we will hear from different situations and different points of view. So not to take more time from the session, now I'm very pleased to invite Nelda Kote from the Polytechnical University of Tirana to present us a paper which is co-authored with 8 other authors. She's the lady with the computer science background, and it's really interesting to see what is the take on universal dependencies in their case, because as I mentioned, there are not many resources on Albania, but they also look at developing a new approach. The floor is yours.
Thank you. Okay, thank you for the introduction. So I'm Nelda Kote, and I'm computer science. I have a computer science background, and in this paper, I am presenting the data set that we have developed during a national project implemented at my institution in collaboration with 4 linguistics and 4 other colleagues from my institution, Faculty of Information Technology. Unfortunately, I can explain morphological annotation in UD because it started during my PhD studies, where I annotated morphological corpus, but going and annotating it from syntax point of view, I think that for me is a little bit difficult, but I have some experience due to the work that I have done in this project. I was the project manager when we implemented it. So I will do an introduction about the situation of corpora in Albanian language dedicated to morphological and syntax annotation. And after that, I will going to explain some details in the annotation. So the annotated tree bank consists in 24,537 tokens, around 1,400 setnas. Is not a big corpus, of course, it's just a small corpus, but to be emphasized is that this is the first corpora that is annotated by linguistics using the UD framework. Also, if you go in the website of the UD, there are two other corpora. One of them is of 60 sentences, but is not annotated from a linguistic, but one of the students that were at the Joachim University for a degree, I don't remember now. And also there is a gag corpora that is one of the dialects in Albanian language, but it is not manually annotated, but it is automatically annotated for morphologic using my older model in automatic annotation morphological, and then after that they have annotated it synthetically. So I give you a panorama of the situation of Albanian language, and I can tell that Albanian language is a low resource language in NLP field. I have mentioned some works done by colleagues before me for annotating in POS or synthetic annotation. Actually, the biggest corpora that exists for Albanian language is the Albanian language corpora, as I know, but it is not an open source corpora, so you can just search on it, but you cannot download it and use it for NLP purposes. In this slide, I have put some statistical about our corpora. So the number of sentence, the number of token, multi-word tokens. If you are familiar with UD, there are tokens that you can split them into main words, let's say. There are some short forms in Albania that are divided like this. The average sentence length is 80 tokens, and then on the second table, I have inserted the most frequent universal POS tag and the DEPREL tag in our corpora. One of the first things that we did when we start the project is the data collection and selection. We have selected the data, so the sentences that we have in our corpora from open source corpora, just not to have conflicts in property rights, and also to have some more complex sentences. We have selected some sentences from fiction books, grammatical books, and the other part is from Leipzig Corpora collection. To mention is that the corpora is in standard Albanian language, so it's the official language, and all the sentences that we have selected and inserted in the corpora are checked before from the linguistics for mis letters, because usually when you write something in Albania, we don't use two letters, and ch nowadays, and there can be some topographical mistakes.
This was because in the Open Corpora Leipzig, there is text that is not correctly written in Albania because they are collected from web. And if you search in web for Albanian content, you can see that there are a lot of mistakes in the text. After that, we have pre-annotated our sentences using the model that I developed during my PhD, but it was just for segmentation, lemmatization, POS, and morphological feature. After that, we manually rechecked all the sentences for segmentation, and after that, usually the segmentation was done by me. So the segmentation of the sentence and also the segmentation of the words or tokens in the sentence. And after that, the linguistics has manually annotated all the corpora. So basically, they have corrected the lemma and POS and grammatical feature, and after that they have inserted the syntactic connection in the sentence. To be mentioned is that we have used a standardized method for annotating. So the two colleagues that has done the synthetic annotation, and the four others that has done morphological and lemmatization, they have agreed before how they will annotate. So they will annotate something in the same way. We use this method because we want to have a standardized data set due to the fact that it's the first data set and it is small. Because in the meetings that they have how to use the UD framework, they discussed a lot and they don't agree usually to use the same tag in the annotation. The annotation process includes segmentation, so sentence segmentation, word segmentation, lemmatization, and for the lemmatization, we have choose to use the Albanian National Dictionary. For this, why I mentioned this? Because usually for adjectives, for example, in Albania, we have a female version and a male version. But in our data set, we have used as lemma of the word just the masculine version, because only this exists in the actual dictionary that we have in Albania. We have used 50 POS tags. Then, depending on the POS tag, we have used some morphological features, and then we have used 32 synthetic tags from the UD tag set. In these slides, I have put all the POS tags that we have used and the morphological feature with each of them. There is an example of one of the sentence with compound verb tense. So the compound verb, the verb in Albania is complex. If you want to annotate it, we have a lot of mood, and in this tree bank, we can see that we are missing some of them. For example, the future, or the compound verb tense. The future is a compound verb tense in Albania that is formed by an AUX verb, so the verb to be, that can be that in Albania is jam and kam, depending if you have an active voice or a non-active voice. So depending, and it's formed with the verb form part, with the particle. So in this case, if we will check the data set, we will not find any future mood in our or tense in our data set, because we cannot annotate it as it made with 2 tokens. And for example, we cannot, if you have a sentence, automatically we cannot decide if you will have one tense in the conditional or the future tense, because they have the same form, but from the context of the sentence, you can understand which verb form it is. So using this kind of annotation. In adjectives, so I have put some of the things that are specific for Albania. In Albania, the adjectives agree with noun in number, gender, and in case. And we have 3 degree of adjectives, but we can annotate just the positive degree, as the 2 other degrees are formed by multiple words, let's say, or multiple tokens, and we cannot annotate it any more. Also, we can have articulated adjectives in Albania, like the example imas, that is big, and in this case we have used the that tag to annotate the particle in our adjectives in this case. We have 7 categories of pronouns, and depending of the category, we have used some of the features. Also, we have annotated as pronouns the abbreviations of pronouns that we have in our language. And in the traditional Albanian grammar, the articles are not treated as a separate part of speech, but due to the schema that we are using, we align it based on the functionality that they have in the sentence by preserving the grammatical feature. This is another example of the annotation of 2 sentences in Albanian language. And in this case, the examples show the use of the root. So, okay, so in the first example, the root is the verb, but when the root is missing, when the verb is missing, we have used, in this case, as the root of the sentence, the word, the noun. And also, I have inserted all the examples for different tags, how we have used them in our corpora, but sorry, I cannot explain every of them. Something that we have done not as UD suppose to be done is the annotation of the COP. So in this case, in our corpora, we have annotated in the first sentence the verb as a root, but if we want to follow the UD schema, and if we want to put it on the website, we need to make a change. And in this case, the root will be the adjective, in this case, that is happy. Because in this case, the Albanian verb jam to be is act as a copula is annotated as a root because in Albanian, my linguistic grammatically they think that the root need to be on the verb. But we are changing these things, and on the version that we will publish on the UD website, it will be according to the UD schema. And we found it after we have finished our annotation in the project, and so we are doing it after that. And I'm going to the conclusion and future work. So adapting Albanian's complex grammar to UD involve challenging, such as lack of direct mappings and ambiguity in assigning tags. And in this case, our database will, our dataset will, when we will finish the correction that we UD needs for us to do. We will publish it online on the website, and it will be open for access. And also, we will retrain a language model, a parser using this tree bank. Thank you. Sorry for not telling you a lot of linguistic details, but
thank you. We started with a couple of minutes of a delay, so if someone has a quick and burning question, we can take it. If not, we will probably take them if we have some time by the end of the session. But Nelda is definitely here, and you can also approach her and discuss. I thank you for this clear and comprehensive presentation. I don't see anyone who is really on fire, so we can move to the next presentation. Thank you very much. So now we will continue with the same general area, but we will move to Romania, and we will look at the experience of using function multi-word expressions annotated with discourse relations in the Romanian reference tree bank. I already mentioned introducing this session that Romanian is the language from the three presented in this session which has most resources. So I think this probably explains why we look at something which is more specific here. This paper will be presented by Verginica, Barbu, Mititelu. I hope it's close to how it should sound. She's a linguist in the NLP group of the Research Institute of Artificial Intelligence of the Romanian Academy of Sciences. And when we chatted about her work, and I asked what attracted her to this topic, she said that this is a very nice combination of two areas she's interested in, multi-word expressions and universal dependencies. So the floor is yours.
Thank you very much. Okay, so now I will talk about something closer to my interests and my heart also. This is work that I did together with Tudor Voicu, who unfortunately couldn't attend today. So this is a pragmatic perspective on data. The focus here is on conjunctions, which is one of the categories of which ensure coherence in text. We wanted to annotate discourse relations of various kinds that are expressed by Romanian conjunctions in the Romanian reference tree bank, which I also mentioned in the morning. And we had two objectives in mind. One was to create a list of possible values that these conjunctions have. And let's say the target will be to include these conjunctions in this connective lex resource, which is like a lexicon of connective devices, a multilingual one, in which conjunctions are added with their meaning, so the discourse relations that they express. And the second aim was to identify the lexical expressions that render different discourse relations in Romanian. Of course, this is not only for creating this lexicon of Romanian conjunctions and their possible values, but let's say the later on aim would be to create a resource from which we can learn and then to automatically identify the values of various conjunctions in text or different ways in which such relations are expressed. So you know that you may have noticed or you are familiar because you work in this domain. In the tree bank, let's say the highest level or the highest, the biggest unit of analysis is the sentence, not a paragraph, not a discourse, a larger discourse unit. So this is the level where we work at the sentence level. And in Romanian, conjunctions, like in many other languages, can be coordinating or subordinating devices at the syntactic level. There is an example of a coordinating conjunction. Precum și, it's not a simple conjunction, we call it a locution. So I will use probably the term multi-word conjunction later on. I don't stick to one term, I tend to use both of them. And this is an example of a subordinating conjunction in Romanian. Now, we didn't create a list of discourse relations of our own. We used the one that was created for Pen Discourse tree bank. And you know, this is a tree bank containing newspaper articles coming from the financial domain, from Wall Street Journal. And these sentences are annotated with discourse relations. And starting from this initiative, there are other teams who develop similar corpora for their own languages, and there are corpora for German, Russian, Polish, and so on. Not many, as you notice. Well, for Romanian, there is interest in discourse relations coming from people who work in, so linguists who work in pragmatics. Unfortunately, although the discourse level was of interest for some important computer scientists, Romanian ones, or people who focused on Romanian, Dan Cristea is one of them, we didn't advance a lot because this is a very difficult, still a difficult level of analysis in NLP. In recent years, I also collaborated with some, well, I'm a linguist, as I was introduced, but from the very beginning, actually, I've been working in a NLP group, but I started collaborating with linguists, theoretical linguists, pragmaticians. There is interest, but still there is not that, let's say, openness that I would like to see. So that we have better collaboration with important quantitatively and qualitatively results. So I still hope we'll manage to solve this problem. But there was a project, there was actually a cost action in which there was a tendency to work to annotate different discourse levels, and There was this work that was done 6 years ago by Sorina Postolea, in which she annotated Romanian adversative conjunctions in Europarl. And she used then version 2.0 of Penn Discourse Treebank annotation manual. In our work, we used the next version, 3.0, but that is the closest work interest to our work here. We chose the Romanian reference tree bank because it's probably the richest and the richest corpus that is also manually checked, so most reliable linguistically. It also contains several texts from several genres, which are enumerated here. And it's annotated using universal dependency principles and features, both at the morphological and the syntactic levels. Well, within this framework, let's say, conjunctions, as Joachim mentioned previously, are annotated where are leaves in the tree. They are not nodes to which other words are linked, but they are leaves. So for conjunctions, we have this special we have this special relation mark, which you can see that attaches the conjunction deoarece to the verb lovit. If I have a conjunction made up of more words, so as we call it a locution or a multi-word conjunction, only the first element in linear order attaches to the verb by this relation mark, whereas all the others are attached to the first element via the fixed relation, which was one of the relations mentioned by Joachim. So the inventory of relations is that that is used in universal dependencies with some adjustments we consider necessary for Romanian. Up to here, everything is according to universal dependencies and nicely presents the Romanian data. However, there is one type of these locutions that linguists treat as a locution. However, we could not represent this as such, so using the fixed relation in UD, because namely the last component, so, has a double role within this structure. So in Romanian is the conjunctive mood marker on the verb. So whenever a verb has this mood, the presence of "s" is mandatory. That's why we wanted to always have it marked as such, as a marker of the verb in this mood. But we have multi-word conjunctions in which "s" is the last element, and you cannot automatically retrieve from the tree bank this information that this string of words for a "s" is actually a locution. Okay. Now, this is the inventory of relations that is presented in the third version of PDTB. You can see that there are actually 3 levels on which they are organized. There are 4 major relations: temporal, contingency, comparison, expansion, and they are further subclassified. Besides, let's say, semantics that's attached to these relations, we have also some pragmatic information like epistemic knowledge and speech acts. You can see here contingency, cause, speech act, which is further reason, speech act, result, and speech act, and so on, depending on the words and the pragmatic information they carry in the sentences. We started from an inventory of 122 Romanian conjunctions extracted from the Morphological Dictionary. These are either simple conjunctions, so made up of only one unit, or multi-word conjunctions. These were 71, but not all of them occurred in or occur in the tree bank we used. And we started annotating from the ones with the highest frequency to the ones which are even hapax legomena. So they have only one occurrence in the corpus. We were two annotators, and each occurrence of these multi-word conjunctions was annotated by both annotators. We wanted to ensure the quality of the annotation, but at the same time, there was interest in establishing which meanings, so which discourse relations are difficult to understand, difficult to identify in a sentence, difficult, to recognize, and so on. In discourse relations, we have one element which establishes the relation, and we have two arguments. And we have we mark during our annotation the arguments and the element that establishes, which is the conjunction actually that we focused on. And after identifying these elements, we assign the relation from the PDTB guidelines manual. So these are the multi-word conjunctions that we annotated. You can see here the number of occurrences they have in the tree bank, and this is the accuracy, so the agreement between the two annotators. With conjunctions with lower frequency, we had a higher agreement, but not necessarily so, as you can see here. It's a difficult task. Yeah, so this disagreement shows that it's a difficult task. Most of the times, the disagreement occurred or appeared when these implicit beliefs or speech acts meanings or types of relations were involved. And here's an example with pentru că or because. These are the results, the quantitative results that we reached after we discussed our annotations. So what we have now is for one conjunction, only one annotation, because after, of course, we read together the manual, we discussed during the annotation, but at the end we still had some disagreements. And after sitting together and discussing them, we reached a conclusion, and we have one final annotation for each occurrence. And these are the results. We can notice that these conjunctions tend to have more than one meaning. So those that have a higher frequency usually express more meanings, more discourse relations. Înainte de seems to be an exception in this case, which means before this înainte de. But usually one such locution has a dominant meaning, or it expresses a certain discourse relations by default, let's say, with a second meaning competing to that, but the competition is not that high usually. Well, in this corpus, of course, we cannot generalize. There was a situation with one conjunction, după ce, which is translated by after in English. And there were 38 occurrences where we couldn't assign only one relation. So we discussed and we considered that use of that conjunction actually express two relations. And this is not surprising because even for Penn discourse tree bank, this is reported and they accept it as a possibility in language. This is the different way of looking at the results, namely, we have an inventory of relations. Of course, this is not the comprehensive list of resources. These are only the relations that we annotated, so that occur in the corpus. And then we can see here what multi-word conjunctions express them. So it's the same data, but in reverse order. Being further annotation to the Romanian reference tree bank, we decided to make it freely available as the tree bank is already. And we needed to make it available in this resource, not as a, I don't know, a derivative in a different environment available or something like this. So we got inspired from the way in which multi-word expressions are annotated in the parsim corpora. And we used a combination of numbers and the names of the relations to attach to the tokens. So those tokens that make up these multi-word conjunctions have the same number. So here you can see that number 1 is used for pentru and că, which is because in Romanian. And only on the first element in linear order, we mark the name of the discourse relation. So it's absolutely identical to the parsim annotation. And if you have more multi-word conjunctions in one sentence, you use another numbers. That's why here we have 2 pentru că, so 2 because in the same sentence, and the second one is marked with number 2. This information is always attached in the last column on the Connell file, according to the practice in the UD community. So each column has a special meaning. We cannot add anywhere else, but only in the last column, whatever further information we attach to this tree bank. So I've presented here, it's the first step because as I said, we worked only with multi-word conjunctions, but the idea is that we need to enlarge this to annotate also simple conjunctions, so those made up of only one word. But these are, as I presented at the beginning, these are not the only types of connectives in language. Adverbs, interjections, and other parts of speech or combinations can also express discourse relations. This would be the highest point to reach, let's say, in such annotation. Another limitation of this experiment is that we focused only at the sentence level, but as we are all aware of, sometimes these connectives express these discourse relations between sentences, not only within a sentence, as we consider. Well, this was so focusing only on intrasentential conjunctions was imposed on us by the fact that the sentences in the corpus are not part of a text. So they were randomly selected from different texts. So we had to adjust to this shortcoming. That was all. Thank you. And now I'm happy to take questions.
Thank you. We now have a few minutes for questions. Do we have any from the audience? Yes.
Thank you, Vergi, for the very interesting presentation. Maybe I missed it, but how did you perform the annotation, like manually or
Yes, it was manual annotation. Yeah.
But preparing for automatic in the future.
Yes.
Any other questions? Yes, there is a question in the. Just wait for the microphone, please.
Very interesting presentations indeed. Do you have any cases of split conjunctions, and how do you deal with that?
Thank you. Split, you mean when other words came?
Yeah,
Yes, we have such cases, but they are annotated as one component at the syntactic level with that fixed relation. And when we treated them, we have pentru ca, some linguistic material, and să. This is the only example that we have in this data asset. Yes.
Yes, I'm asking because I'm working currently on complex prepositions in Bulgarian, and that's a very common situation. So yeah, I'm actually, and it concerns not only prepositions but conjunctions too. And yeah, I'm actually surprised that in Romanian there is only one such conjunction
in this data.
In this data. Okay. Good luck. Very interesting. Thank you.
There was a raised hand in the back.
I thank you for the presentation as well. Like a continuation of the previous question, are they like fixed in form, or are they what sort of the components? What sort of words are they?
So you mean if they these locutions are made up of content or only of function words?
Do they contain content words in any way?
Content words?
Yes.
Yes, they can contain.
So they are more complex.
But these content words do not inflect in these locutions. So they have a fixed form.
Okay. And also my second question was going to be with the inter-annotator agreement that you mentioned, and some of the values were like 30%, below 30%. So I was wondering whether the lack of agreement was that this is a compound or just the meaning.
Actually, there is one point in the manual which tells you how to consider the arguments. So which one is the first argument, which one is the second. And there was a misunderstanding by one annotator of this problem, and this generated the high disagreement in those cases, because you can start with the conjunction, so with a subordinate clause, and have the main clause at the end of a complex sentence. And Tudor considered that the subordinate clause was the first argument and the main, because in linear order, but actually in the manual they clearly say which is the first argument in the relation and which is the second one. And afterwards we discussed and we agreed upon this.
Okay, thank you.
That was the problem.
Okay, last question from anyone? I don't see any questions from the audience, but I was curious, if you move to another set of data, not legal text, but different subject domain, what do you expect will happen with your way of work? Would you need to adjust it?
We don't have only legal data. We also have imaginative text here, medical text. We try to find some correlations between the text genre and the relations, and it's not big, large corpus. We couldn't find any correlations yet. We'll see if we enlarge the data.
Thanks very much. Thank you. So now, last but not least in this session is the paper by our colleague from Sofia University, Atanas Atanasov, who is specializing in the domains of syntax and computational linguistics. He will present to us his work on a dependency parser for Bulgarian, a domain which builds on his experience in syntax, obviously. And he said this is his first attempt to move into the NLP domain. So I hope you will give him a very warm welcome and also nice feedback how to continue swimming. I think everyone is swimming today in this area.
It's deep waters. Thank you for the presentation. Good afternoon, everyone. Well, obviously, I'm going to present my dependency parser for Bulgarian. And let's start with a few words about what we're gonna see in this slides here. I will show you part of the implementation and mostly the evaluation of the model, the neural network of this dependency parser for Bulgaria. It's built with TensorFlow and the Keras API, and well, logically, it uses the Bulgarian universal dependencies data set. And actually, this is a kind of partial work. I mean, the parser is working well, but it is not includes part of speech or lemma recognition and so on. Here, the focus is entirely on the dependency analysis itself. So for prediction, I use another libraries. I will show you later in the next slides what's going on with them. So all the scores and all the results are based only the labeled and unlabeled score here. This is what is the goal. And well, a little bit of background here. First of all, the grammar concept, of course, for dependency parsing, everyone here knows we are using dependency grammars as the other main approach in linguistics in the last decades. Generative grammar is mostly used in theoretical linguistic studies, but dependency grammar is more appropriate for practical tasks, and especially in the field of computational linguistics and, of course, universal dependencies data sets, and and the parsers built based on these data sets. We heard before a while very interesting lecture on this, so I will skip this part for universal dependencies, and we'll say a few words about the main approaches for these parsers that are used in NLP, transition-based, or the so-called shift-reduced parsers, and the graph-based models. The transition-based parsers actually are faster because they are using kind of movement from stack to a buffer, and they are working with partially built tree, doing some operations on it. And graph-based models took all the possible trees, syntax trees, and choose the one with highest score, which means it, at least in theory, should give better results, but this came with a cost with, of course, bigger time complexity. So they are slower, but more accurate. And what I'm going to present you here are the results of such a graph-based parser. And it follows the model proposed by Dozent and Manning, which is called Deep B-affine attention model. And this algorithm looks like this. This is actually the picture from the original work. And first we have some BLSTM levels in the architecture, which are fitted with the sentence inputs, the embeddings, and they extract the useful syntax and semantic features and give them to the MLP levels, which transform these features in a format which is suitable for this last level, which they call BFine attention levels, which actually are doing the predictions of the arcs and the relations. So this model is used as a starting point from this parser I will show you. About the data, I already told you that, of course, I'm using the Bulgarian universal dependency data set, which is composed by about 11,000 sentences, which are split in the convenient way for machine learning tasks. It means about 80% for training data and 10% for development and for test data sets. So no additional split is done here. I just use them out of the box as they are provided in this case by TensorFlow datasets. For inputs in the algorithm that you saw before by Dozent and Manning, they are actually using as inputs only this two. Only the tokens and the universal part of speech tags. But in my model, I decided to add two additional inputs. These are the lemmas and the morphological language-specific characteristics of the words. We will see on the next slides what is the difference as a result, but it gave some boost to the model. The next step, of course, is to build vocabularies, which in this case are just TensorFlow hash tables, and finally vectorize the data to feed it to the model as model inputs and go to embedding layers. The model architecture looks like this. Well, I know it's too small and we can't see much of it. That's why I put some labels on a side. Well, first are these input levels, the embeddings, but here they are. We have 4 of them instead of 3. Then we concatenate them. Before that, they go through very strong regularization. I will talk about this later. Next come these BLSTM levels that we saw in the previous slides, and the MLP layers. But it is important that we have a very, very strong dropout between every level, literally. And finally, we have the BFine attention levels. Also, the model is using the Adam optimizer and is provided with custom loss functions and well, let's move to the next slide about the experiments and results, as here is the most interesting part. As I said, the original dropout that is proposed by Dozent and Manning in their work is 0.33. But for languages like Bulgarian, I mean very morphologically rich languages, stronger regularization occurred to work much better, and the difference is more like 0.5% with the same hyperparameters. It's actually 0.66% increase of the model performance with dropout 0.5, and for both unlabeled and labeled attachment scores. This, well, from one side, it's at least in my opinion, connected with this, that Bulgarian is highly inflected language. But from the other side, the authors here, I mean, Dozat and Manning, they have tested on much bigger data sets like English, Czechs, Chinese, and so on. And Bulgarian being so small, strong regularization helps to prevent overfitting. So this is another possible reason for this improvement of the model that way. Next, the learning rates and decay rates. I have experimented with, instead of using the integrated Adam decay, to use exponential decay between these two values that you see on the screen. But unfortunately, this didn't give me the results that could improve the model. Actually, the best one achieved between these values were slightly worse than the best values the model achieved without using exponential decay. Really slightly below, but still below. So maybe a little more fine tuning here could give better results, but I don't think it's gonna be very beneficial. If they give better result, it will be slightly better. So the corrections of the batch size, the best score I achieved was with batch size of 128 and with 80 epochs. I tried to play a little bit with these values, and well, usually bigger batch size, at least in theory, should give better results, but in this case it occurs it's the opposite. With bigger batch sizes, I received lower results, and as you can see, it's not so small drop down here, more than 0.5% for both labeled and unlabeled score. And the reason here should be, again, the size of the data set, which is only about 10,000 sentences. And this way, with the big batch size, it can generalize well, because from one side, it maybe overfits the data, and it can't go through entire nuances of the data set. And the smaller, the other option, when I actually decrease the batch size and increase the epochs, the results were very similar with the best one achieved with the optimal one. So in this case, with smaller batch size, the Bulgarian data set works best, at least with this algorithm. Another option that I have changed several times was the input levels. And as I showed you on the previous screen with the model architecture, adding lemmas and the language-specific morphological information as input layers actually gave the most boost to the model. And here we have 0.86% for unlabeled score and 1.31% raise for labeled score, which I think the reason here should be the Bulgarian being really highly inflected language, and this language-specific morphological information gives the needed information to the algorithm to predict better. And finally, at least to here, this model has nothing to do with the large language models, but sooner or later I should think about it. So I just try to replace only for the tokens when I vectorize the data to replace the standard TensorFlow embeddings with Roberta embeddings. And actually this gave me a little higher results. We can see them here. Well, it's 0.21% for unlabeled and 0.5% for labeled score. So here we can see actually the power of large language models, but this is a little bit fake because actually I used this Roberta embeddings only in the pre-processing the data, not in the model itself. And I believe if I put this Roberta embeddings in the model, it will have a greater impact. And the next slide shows the results of this model compared to some of the most popular parser that has connected Pepper, which reported result for Bulgarian. Well, Spicy, NLP-Cube, UDPipe, UDFi, and this one here, the second. This is the implementation of the same B-affine attention algorithm, just like it is described by the authors, Dozent and Manning. And this one here is with the improvements, with the additional layers and change dropout and so on. So as you can see, it's slightly better than some of the previous parsers, but of course it's still not as good as parsers like UDFi and some others. The reason for this is that from one side, UDFi is trained using large language models, and it uses BERT. It's much, which makes it much bigger. Well, my model with Roberta embeddings is about 30 million, and here we talk about billion parameters down there. And the other thing is that UDFi is trained on all the universal dependency sets combined together, concatenated and trained on them. So this gives additional advantage. So here I will try to find some improvements. Okay. About the prediction and visualization, as I said, this parser for now doesn't predict part of speech, so I had to use some other library to process raw text. So here I'm using Classlo for the moment, and now I'm working on the part of speech parser, but it will take some time. Then the text is converted to the well-known CoNLL format. From there, it is converted to displacit bank, and it has a model that can visualize the data. So the final result could look like this, for example. And a few words about the future work. Of course, I have tried many hyperparameters, but their tuning is never enough. So I believe here I can get some additional boost for the results. Of course, better embeddings, and especially the ones, well, most of the models of this CoNLL task use BERT as their nuclear But I think BERT in this case is the better choice because it supports better this low resource languages that Bulgarian unfortunately belongs to. Of course, integration of a part of speech and other morphological prediction, and the model would be good to be evaluated with other highly inflected languages like the other Slavic languages to see if it will give any advantages there. And thank you for your attention.
Thank you. I have to thank really all the presenters for preparing in such a nice, clear and focused manner. Do we have any questions to Atanas from the audience? Yes, please.
You have said about future work of testing that model on other Slavic languages.
Yeah.
How much work would it take to boost other universal dependency from the side?
Sorry, how much work?
Would it take to, for example, take Serbian universal dependency, which are also on universal dependency?
Actually, the model now can work with any data set, but it is optimized for Bulgarian. I mean, all these tests and evaluations that I made were on Bulgarian. And I didn't look for the other languages, how they are impacted by these changes. But actually, it can work with any other data set.
Okay.
Thank you. You've mentioned several times that Bulgarian is a high inflected language and this influenced the results, but why do you think so? Because Bulgarian is highly inflected considering the verbal morphology. It's not case marking language. What do you think, and what actually is your reasons to mention this?
Well, the verb is a significant part, and compared to the between 3 and 5 forms in English, the 52 forms of Bulgarian verb.
Yes, true, but how this influences the universal dependencies, how this influences the dependencies at the syntax level?
Yeah, it influences, in my opinion, the prediction of I mean, it's much easier for the model to learn 4 forms of the word than 50. And when we have stronger regularization, this helps to generalize these additional forms that we have.
Is this about the balance of the number of verb forms and the number of noun forms?
Yeah, actually, well, Bulgarian is analytical language looking at its noun system, but the verb system says something else. But yeah, it's definitely more morphologically more rich than English.
Okay, maybe you can continue this in a personal discussion. Any other questions? Yes, there is a question here on the side. And then for this event and this session, we will be rebranding the coffee break into a water break. I think it's very important to stay hydrated. So, yes.
May I not stand? May I sit? Thank you. Nasko, how do you plan to use your dagger afterwards? What is your plan afterwards?
Well, my first plan is to finish my work with it. It's absolutely open source. It's uploaded in a GitHub repository, and everyone can use it as he wish.
Do you mean to integrate it into any other system? Do you mean to relate somehow to the work of Kirill and Petya, to the work of the group of Svetokova?
Yes, it's already integrated with their work because...
Yes, you've used
actually, the data set is made by them, and the class library I use now is also by their theme. And no, actually, I didn't think about future implementation of this parser, but
maybe you have to.
Yeah.
Thank you.
Sure.
Okay, thank you. Before finishing this session, I need to ask if anyone has a question to Nelda, whom we didn't interrogate. Is there any question for her? I know that she had a bit of a chat with some other participants meanwhile, but okay, I don't see anyone. Okay, I think this was a very informative session. Thanks to all presenters. Thanks. Okay, thanks also to all participants. We will hear an announcement from the organizers of the event.
So a couple of things. First of all, tomorrow the temperatures will drop by 10 degrees. So outside. So dress more warmly than today. And second of all, today, this is a good opportunity to enjoy the weather today by joining us on the guided tour around the landmarks of the downtown Sofia. We will be guided by an archaeology graduate, so feel free to grill him about the history of Sofia. And then we suggest that we meet up for discussion and dinner at a restaurant where we have made a reservation, and everyone pays for themselves. That's the important thing. So just the address. Okay, so this is shared. On the webpage? Yes, it's on the webpage, but I want to show it anyways. So, okay. So on the social program, you have the walking tour, and this is the map for the restaurant. It is located at 33 Petar Pačević Street, so very close to Vitusha Street. Okay, so feel free to grab some coffee and water.
Do you want to share the slides?
No, somebody told me it's a good idea to, I agree. I go on to Nešport Barska. All of the crowd. It's Latvian MVs. Yes, I guess. No, number 2.
Okay.
How do I guess?
Yes. Wait.
I just okay. I just okay. I'm trying. Okay, everything looks like working fine. Super. I just put it down, I guess. Nothing. I just somebody told me have a look if everything looks like in my. She told me I
Искаш ли да пуснеш този екран, дето е като...
Mai даже отстрани или защото ми се стори, че има дупка по средата преди. Да. Сега ми се стори. Няколко човека стъпваха отгоре, но ще се... Това много не сме развалили тези се.
Не, това е кабел сам. Кабела, какво ще му се случи? Когато искаш, случни обратно на тук. Една минута да почваме.
Всъщност има ограничение за езиците, за да си го колеги са на разположение.
Там системите са еднакви училища. И съответно това училища, които не е тази селекция. Ние започваме да правим алтернативен конкурс, който е за същите текстове, но наградата на 90 не е сложна. Това е по-морална награда и за много повече деца да не се лично. Това е усещането на конкурса. По същия начин се време, обаче избираме ние най-добри. Аз сама началото на бяха до 13 работи. Аз 30 и успехме. Документи има много време. Това не е основната работа. При студенти, време на група, да оценяваме мисля, че това е стане месец. Можем да оценяваме.
Всичко, което е необходимо за
Можно естествено, если
Добре, според така пише и аз фонетично се опитвам да се представя.
Hello again. Thank you very much for your patience.
And I would like to assure you that we're doing everything humanly possible in order to change the comfort of this room. And I'm really glad that you have stayed, although the atmosphere is really summer here. So for tomorrow, we are going to try to have somebody see the technical equipment in the morning before you come. And also we are going to open the windows as from 7 o'clock so that we have a bit fresh air from the morning. So hopefully we're all going to be a little bit more comfortable tomorrow. Thank you very much. And excuse us again for this unfortunate circumstance.
It's quite natural. It's summer. We're imagining that we are at the seaside. The sea is beyond the horizon, but good afternoon. I have the pleasure and the honor of chairing the last session. Last in time, the timetable, not of course last in relation to the interesting topic that it is dedicated to modeling multi-word expressions. Our first presenter is Miss Andrea Dinka, who is going to present to us the teamwork of several people dedicated towards a Romanian phrasal academic lexicon. The floor is all yours.
Hello, everyone. Thank you for resisting until the end. I'm very happy to present this piece of research from the group that worked on it. So it's a collaboration between 2 universities in Romania. 3 of us are from the West University of Timișoara, from the CODUS Center. And then we have Ana Maria Bucur, who is from the University of Bucharest. Now, the motivation behind this research actually comes from a gap in resources for academic writing in Romanian, especially when compared to English, where we can find a lot of learning and teaching resources for learning academic writing. And you probably know how hard this is, especially for students and early career researchers to learn how to write and publish internationally and nationally. And that's why we would like to fill in this gap and create a Romanian phrasal academic lexicon to support academic writing in Romanian. Okay, just briefly, I'll talk about the research that has been done on academic multi-word units internationally. So the majority of research has been conducted in the field of English for academic purposes. And the main goal was to develop a core academic phrasal lexicon that could be used across disciplines, so that researchers from all disciplines could have at least a list of phrases that they could use in their writing. These academic multi-word units are usually extracted using computational methods, and then they are assigned rhetorical and functional categories. The focus is usually on those phrases that can help writers convey their message effectively. And I will give you some examples here, some learning resources. So this one is very famous. It's called the Manchester Academic Phrase Bank. And the top is, let's say, the functional category or the rhetorical category. So, for example, if someone wanted to talk about the lack of previous research on a specific topic, they could maybe use some of these phrases to glue their discourse together, let's say. And maybe, I don't know, if they are discussing findings, they could use some of the other phrases to discuss their phrasing, their findings, sorry. Another way these phrases have been used are in creating learners' dictionaries. So this one is from Oxford, and it's a website with these phrases that have been extracted, and they can be filtered based on some categories. Again, if, for example, if you wanted to compare something, you can select, and the platform will give you some phrases that you can use. And lastly, they have been integrated in AI writing platforms. I have here one example, it's Writeful. And here again, you can see how they integrated it. So they took it and used it as a phrase bank. And they also use it to give feedback on one's writing. Okay, so we have all these resources for English, but unfortunately for Romanian and for other under-resourced languages, not that much. That's why we have some objectives for this study. So first, we want to create this Romanian phrasal academic lexicon that we are going to call ROPAL. We want to annotate these phrases based on rhetorical functions, and we compared these phrases across expert and student writing in order to validate our lexicon. And then we wanted to verify the capacity of ROPAL to support automatic assessment of academic writing in Romanian. Okay, a few words about the methodology. So we used two corpora, the Express corpus and the Roger corpus. So Express is a reference corpus of Romanian academic writing. It's about 3 million words, and it contains one genre, and that is research articles taken from high-impact journals. And we have a few disciplines covered. We have economics, linguistics, IT, and political science. Then Roger is a learner corpus of Romanian student writing. And here we have quite a lot of student genres, such as essays, research papers, BA theses, and so on. And it's about 1 million words. And the disciplines are, again, economics, humanities, computer science, and political science. These were built at our research center, so we wanted to make them as comparable as possible in terms of disciplines. And we also used the Romanian academic word list, which is a set of academic words that are frequently encountered in academic texts. It is derived from the expert corpus, and it's a list of 673 lemmas distributed among the main part of speech categories. Okay, and now I'm going to tell you how we developed our lexicon. So the lemmas from the raw AVL list were used as node words, and we extracted collocations of 2 to 6 words from Express containing the raw AVL lemmas. We did have some criteria for this extraction, so a collocation had to occur at least 10 times per million words and had to occur in a minimum of 5 different texts. We had to do some manual filtering as well, because we had to remove the shorter collocations that were part from larger phrases. And we ended up with 794 collocations. We have more 2 grams, and then 3 grams, 4 grams, and 5 grams. Here you can see a table. So we have the collocation in Romanian, and we also provide the English translation. Okay, we then classified them. We tried to classify them. We looked at models like Opal and Manchester Phrase Bank in order to categorize them. Unfortunately, since Romanian academic writing is a little bit different from English academic writing, we couldn't just take those classifications, and we had to adapt them. And here we had to use the expertise of the team in Romanian linguistics and didactics. And we came up with 10 categories. We developed these categories for the first 129 phraseological units on the list, because this was done manually, so it was quite labor intensive. We had to look at contexts and verify. We had to check with each other, so we couldn't really have the time to do it for everything. But we believe that it's a good enough sample to start with. Now, some of the categories are quite similar to the English ones. For example, talking about literature review or giving examples and so on. Here you can see that we also have one word. Well, this is the examples translated from Romanian, but in Romanian is 2 or more words. Okay, now in order to validate this lexicon, we performed some tests, and we wanted to see the coverage of this list, first in the corpus of expert academic writing, and then in the student writing. And in the expert writing is, of course, bigger, as you can see. Even if 3.6% seems quite small, it's actually in line with previous research that has been done on English academic writing. So this is also encouraging. Then we searched the top 10 collocations in the Roger corpus, so in the student writing. And we actually found an even poorer representation. So you can see here all these zeros. We could hardly find many of them. Now, these tests highlight the differences in academic phrase use between expert and novice writers. Okay. And then we took this study one step further and we looked across disciplines in expert writing. So we wanted to see if researchers used those phrases differently depending on the disciplines they came from. And we did actually find some interesting things. So it turned out that in economics and in information technology, they used more specialized phrases, usually related to technical aspects, as you can see here. I don't know, maybe growth trend or database analysis. And they focused less on the discourse itself. And this was very different from the political sciences and linguistics, where they use more rhetorical strategies, such as introducing multiple perspectives and discussing sources, using more connective phrases, as you can see here, from the point of view, on the other hand, and so on. With all these interesting findings in mind, we actually developed a pilot ROPAL list that is freely available and can be used for educational purposes. So every teacher can take it, can print it out, can use it for exercises in order to teach their students. And of course, this list is also available online for other computational applications. Okay, now I'll just move on and briefly talk about some conclusions. So we are actually quite happy with the results because the lower coverage percentages in the novice writing when compared to expert writing actually validated ROPAL's utility for using it to assess academic writing proficiency. And we are happy that we could also provide a pilot ROPAL list that can be already used. And of course, we do have plans with it. We wanted to adapt it to various disciplines and investigate these differences even more. And we would like that future studies could use this list for AI tools that could be used at text correction, suggestion, and assessment in Romanian. Thank you. And if you'd like to know more about us, here, this is the link of our research center. And I'll be happy to take questions.
Thank you. Now the floor is yours for questions, comments. There is one raised.
Congratulations for your work and your presentation. I was wondering if for each expression that is presented in each category, do you also provide examples for potential users, I mean, so that they know in what linguistic context they can be used?
Right now, for this resource, we don't have the examples. We only have let's say the title of the categories. But yeah, in the future, we would like to do that. Actually, the Express corpus is freely available, so teachers could actually use it with their students and maybe search those terms, and they can get phrases, yeah, and examples. But yeah, that's definitely something that we would like to do.
If there are no further questions, I will abuse the floor. Okay, may I ask you a question? I think my voice is... Sorry. Okay, when you were commenting on the differentiation between the phrases used, multi-word expressions used in economics and linguistics, for example, the ones in economics sounded more like terms, while the ones that were listed for linguistics sounded more like these here, rhetorical, whatever devices you can call them for constructing a text, while the economics one, such as growth trend, obviously is a term. How do you tackle this differentiation in your work between terms and...
Well, for now, we just extracted them, and because we also wanted to see the frequency, and actually these specialized terms were very frequent in economics and information technology. So this was based on frequency. So I took some examples to show the difference between, let's say, the discourse. So in linguistics and in linguistics, we had a lot of connective phrases, and those were the most frequent. While in economics and IT, the technical words or the specialized phrases were the most frequent ones. Maybe not growth trend appeared the most, but phrases like growth trend and the other ones.
So are you going to go into subject specifications?
You mean by
subject area?
Yes, yes. This is what we want to do. Yeah.
Well, another question.
It's not a question, actually. No problem. It's a suggestion because you are working with such devices where punctuation is also very important for users of a language. And because, I don't know, I haven't seen within the Romanian community so much emphasis on punctuation in recent years. Maybe now that they have announced this îndreptar, there will be more interest in this. But I think punctuation is very helpful. And you should also provide information for users when commas are important and so on to be used with these connective devices, because that's what they actually are.
Yeah, definitely. Yeah, that's a great point. Thank you.
Okay, let us thank our presenter then. We have the floor. Excellent presentation, and without further ado, invite to the mic our next presenter, Ms. Gunther, and I apologize for the...
It's fine.
Thank you. You, okay, cleared the egg from my face because I didn't know how to pronounce that. Who is going to present to us work, again, teamwork, on word expressions in the Latvian monolingual electronic dictionary. Yep. The floor is all yours.
Thank you. Good afternoon. So I am going to talk about our dictionary, Thesaurus. What is it? It is by far the largest Latvian electronic dictionary. It has more than 400,000 entries, and among them are more than 71,000 entry of multi-word expressions. The dictionary is compiled from many prior sources, dictionaries, databases, all the printed dictionaries in Latvian history, and so on. It's constantly being supplemented, revised, improved, and so on. For now, it works like a hub for all kind of lexicographic information with different links between entries and so on. And in this study or experiment or we address the very, very diverse group of multi-word entries in this dictionary, as information comes from so many different sources. As different as the sources are these entries of more than one word. Yeah, during the last 2 years, not all the years, but in some
some weeks of these years, we have been manually arranging this big amount of data in smaller, more uniform groups. Of course, there are very many definitions of what a multi-word expression is. Yesterday, we could hear most part of them, but for us, as it was not a problem for us to extract or choose these expressions because they were in kind given to us. We had many of them. Maybe some of them we like better, some not so good, but okay, we have as a set of data already. So we adapted very practical for us and simple definition, the last one. Multi-word expression, it is a lemma in a dictionary that is made up of more than one orthographic word. So it's quite easy to distinguish for us what is and what is not multi-word expression for this our purpose. Why we did that I think it's quite understandable, because we had a very great amount of data in, let's say, one category, and there was everything, and still is. Terms, phraseological units, different proper names, conjunctions of more than one word, and so on. Really very different company. And of course, we already see gains of it. For our dictionary users, of course, these entries now have become more easy to understand, to read. There are some additional information. And for us, for lexicographers, it's also there are some groups to work with further. And finally, we have some idea, what do we have? Because before, okay, yes, we have some terms, some idioms, something, but we didn't have a clear idea how many. And really, is it hundreds or thousands or what? Now we have already some idea. How did we do that? We have a group of linguists at our institute with different backgrounds, different expertise, different everything. Then we invented, let's say, a list of possible subgroups of these multi-word expressions and some criteria for distinguishing them. Then we created a very simple tool for classifying these things into database and just try to do and just to see what happens. The tool looks like that. There are given for the annotator list of multi-word expression with definition, just expression definition. For some of them, some additional information. If there is like discipline where the term is used, or is it colloquial or what? And these letters correspond to groups where they are sent to. So if we push the button, then this multi-word expressions goes to terms or idioms or somewhere. Yeah, no, it's just one entry in our dictionary. Jura, it means sea. There is first meaning, something, example, and then a lot of multi-word expressions. And okay, I won't translate even it. Just we can see that after every expression, we have some word tag, and it means is it collocation or term or taxon or something. It's not for users visible already now. What groups did we invent? First one, it's multi-word terms like active voice in linguistics or rhesus factor in medicine and so on. So terms consisting of more than one word. Then we have very many proper names in our dictionary, mostly place names, but not only. For example, Baltic Sea, Papa Village, and so on. Then, as a separate group, we decided to make taxonomic group names. It's biology, all about species and gentes and so on. They can be both Latin-based or Latvian, because just we have very many them in the dictionary, and for us it seemed it's quite easy to distinguish, so let it be a separate group. And then linguistically, for us, most interesting group, it's phraseological units. In Latvian tradition, we divide them into phrasemes and idioms. I will, in more detail, tell about next slide. And the rest was just collocation, where for us collocation is just a fixed word combination with no semantic reinterpretation. But somebody has put it in the dictionary, so we have it. In practice, this category includes most of the multi-word expressions that didn't fit in other categories. And okay, it's some future work to distinguish them further. Okay, phraseological units. Okay, all of us know what they are, but they usually are expected to comply with some fundamental criteria. They are more or less fixed, consist of multiple words, and they possess some degree of metaphorical meaning. And in Latvia, yeah, we have strong tradition to divide them further. Phraseme in idiom by the divisibility semantic. Phraseme, it is multi-word expression where at least one of its components retain its normal sense, and idiom when none of the constituents are used in their literal normal sense. So the idiom as a whole means something entirely different than the words. Examples, caurs miegs, it means poor, bad quality sleep, but literally translating it's like leaky sleep or sleep with the holes. You see sleep, it still means the sleep, but this word caurs, leaky, has nothing to do with quality outside of this expression. Also, slinks, kā mais, it means lazy as a bag. Not lazy, it is lazy, but bag has nothing to do with very lazy. But idiom, karāties, mata galā, literally it means to hang by the end of the hair, somewhere here. And it means to be in the dangerous situation. Of course, the meaning doesn't follow from the components. And also to do something, ar gariem zobiem, by long teeth, it means to do something unwillingly. And so we also in our classification try to separate these two things into two separate subgroups. What did we get at the end? So in our dictionary, the biggest group was of these complex terms. Then came multi-word place names, some other proper names also among them, but not very many. Then very big group, there are taxonomic group names. Then our favorite group, phraseological units, is not that big, but big enough. And we see that idioms in the dictionary is more than phrasemes. And there are some cases where we can't really tell what is it. And then we have some 3,000 of other collocations. And as usual, some part 5,000 of it is not still classified for different reasons. Of course, in real life, nothing is that easy. As you saw, our division is based on different criteria because our aim was to make groups which won't be difficult to distinguish, though maybe the criteria can be different. And so criteria are figurativeness. Phraseological units should be figurative, while collocations not. Then by functions of use, so terms are used in specific discipline with specific meaning and so on, and simply by theme, let's say, because taxonomic units all belong to the biology. as every classification here also we have borderline cases, so expressions which could be sorted into more than one category. Terms and taxonomic group names can also be figurative, but still they are not classified as phraseological units. Also, collocations sometimes can have some degree of figurativeness, and then there's question when it's figurative enough to be phraseologism and when not. And this division between phrasemes and idioms in practice not always is easy to do, though yeah, it's here about that. In practice, this definition, at least one of the components retains its literal sense, is not always clear enough, because we very soon got question, should this literal sense should it be the basic sense of the component, or can it be some secondary sense, or what? Because if we take all the senses that is in dictionary, then almost all the phraseological units becomes phrasemes, but our intuition says that it's not good at all. So in future, we think that we should add something more to this definition, at least that the sense should be direct. So the future work in this part of classification is to think about once more about this classification of phraseological units or criteria for distinguishing them. Then there are already mentioned borderlines between terms or taxonomic units and phraseological units. So, for example, taxon, apšu kundziņš, it's a mushroom. Literally means aspen, a tree. Yeah, Lord, it's such a beautiful idiom, but still it's taxon and term, and yeah. So in these cases, we decided that functional criterion comes first, and if it's a term, then it's classified as term, not regarding its figurativeness. And the same is with different other term. Aus gliemene, it is that part of the air, and literally it means air clam or air snail, but yeah, it still is regarded as term, not as a phraseme. Also, borderline cases between phraseological units and collocations. Yeah, multiple word unit was classified as a collocation if all of its components was used in the sense that we can find in dictionary. Again, there is some questions about in which sense, but all the same. But we have examples, as yesterday it was mentioned, like phone book. It was similar the example. That has some certain degree of figurativeness, but it's fading. Many language users no more feel it as meaning transfer. For example, good eyes, with meaning good vision, of course. But is it phraseme? Maybe not. So, and also, celt trauksmi, it means to raise the alarm, meaning to make the alarm. Okay, yes, there is some meaning transfer, maybe used to be, but these are so often used expressions, so we don't feel it anymore as like phraseme, and so these were tagged as collocations. And as we know, some phrases can be used both as idioms and collocations in different meanings. For example, atmesta roku, it's wave one's hand, and we can mean really a gesture when I say no or go somewhere. Then it's literal meaning and collocation, and it can mean also to stop doing something or abandon something where there is no gesture. And then it's idiom, and the same is grozīt galvu, it's like that, turn head. And when it's literary, when I say no, it's collocation, but it can mean also to think very hard, very intensely, without any gesture, and then it's idiom. In these cases, we have possibility to assign two meanings of the phrase, and then both tags are put there. So, conclusions. The multi-word expression classification created so far, we think is a very good first step for semantically functional systematization of all these multi-word expressions that we have in thesaurs. Of course, just first step. Some borderline cases and overlapping of groups, I guess, are inevitable. Various level of figurativeness complicate sometimes the distinction between categories, but nevertheless, we for now have some more or less clear groups, terms, taxa, also proper names that are taken away as more or less ready groups. And then we have two more diverse groups, phraseological units and collocations that needs further classification, further research, but now we have more uniform groups to work with further without this noise of terms and proper names and so on. So, thank you. Everybody seems to be in a hurry to get out of this. Okay, very pleasant room. Thank you for your presentation. The floor is yours for questions and comments. Oops.
I just spoke about the classification for dividing the expressions into several groups as if it were a one-dimensional thing. So all the groups on the same level, but in fact, from what we heard, there's room for talking of at least two dimensions of classification, one being the domain of use, so whether it's a term used in some specific area, and maybe that toponyms and geographic concepts and things having to do with biology, which may be subcategories of the first one. And then a totally different dimension would be the degree to which the parts of the expression retain their literal sense or replace it with something secondary meaning, peripheral meaning, metaphorical meaning, or very special meaning, in which, for the purposes of this particular MWE, but nothing else, the word gets a meaning that doesn't have anywhere else. So it seems to me that, as I said, at least two dimensions, maybe more.
Yeah,
the classification could be.
That's why I said it's the first step. Of course, we are aware that we need to add something and to put this, that we don't have to choose to put there or there, maybe both tags. This was just empirically because we started this experiment. These groups needed to be clickable because the first thing was to this great amount of data to put at least in some categories, because if we to have some idea what we have, and then now when we did that we of course already have so many ideas how to elaborate this and how to put these things. That term can also be figurative, everything can interact, yes, but as we had not long time, then several colleagues that were for these weeks taken away from their projects just for clicking to test our ideas.
then we did like that. But yeah, it is good start to see all these problems, interesting things, and go on. Yeah. So it really work in progress.
Another question there.
From your example, or with with one example with shaking your head. So I noticed there that that's actually a word with multiple different senses, because we have a literal shaking head. We have a little less literal when we are denying something. Is it denying or expressing doubt? And then we have a completely, is it not?
No, here, grozīt, the literal sense, I mean, this shake, no, grozīt galvu, shake, it's denying only, no, in literal sense. If it's about head. No, I mean,
it doesn't mean just moving head, like, for example, for exercise.
Grozīt, yeah, maybe, no, I mean, yes, it's physical meaning, not exercise, but looking around or saying no,
yeah.
But saying no, actually. Oh, yeah, okay.
So I'm just going to say by that example, normal words also can have multiple senses. So maybe just instead of putting all tags on one multi-word expression, we should treat them as separate words. I don't know.
Here we have, as I mentioned, we in dictionary already have this expression, and it comes as an expression actually in the dictionary. The reason to put it in the dictionary was that idiomatic sense. But if we put this meaning, we can't neglect others. So we have to say, for, let's say, language learners, that it doesn't mean only thinking hard. It can also mean this simple gesture. Yeah, I think that is it. If it wouldn't be this idiom, then no reason to put it as a multi-word expression in this. When it's just physical, everything I can move.
There's another raised hand at the back.
Besides meaning for these idioms, however you call multi-word expressions, is there any other linguistic information attached to them? So do you present their structure? Do you present possibilities of combining them with other words, so valencies if there are?
Not yet, but in few weeks, I hope the tool will be finally ready for assigning this variability in syntactic, which of components are flexible, which are not, and so on. We are waiting for computer scientists to finish our tool. So it really is everything in progress. Yeah.
Thank you very much.
Any other questions? Then I have a tiny one. What's the utility for you?
I keep forgetting. I'm really sorry. Okay. What's the utility of this very refined differentiation between idioms?
Idioms and phrasings.
Yeah, for users, because you said that at this stage, the goal is to make it user friendly.
Yeah.
So how would
it's? I'll answer. The question is not very simple because there are different users. If everyday users, let's say that. First thing, very, very practical and simple. At school, teachers make pupil to try to distinguish them. So it's useful to look up, what do I need to answer in this? No, it's just practical. In other level, okay, we will test it when the tool will be ready. But we think that idioms will be more fixed and phrasemes will be far more like flexible, more variations or so on. But it's our idea, we should test it. And of course, yeah, this tradition, but from the other side, when we now clicked a lot of them, we also had this question, to ourselves, because, okay, we started it because we couldn't do otherwise, because all the tradition made us to do that. But now, I don't know. Okay, I think we for sure could take out idioms because they are very idiomatic and so, and phrases, maybe let somewhere. I don't know. It's work in future, but yeah, it raises questions. But we will see.
So we will be waiting for your next year's presentation
Maybe,
where
let's
you
see.
will tell us the results.
In 2 years, yeah.
2 years, okay.
Okay.
Any other questions or comments? Let us
Go on, yeah.
thank our speaker. And of course, invite our next presenter, Laura Pinti. I apologize for any mispronunciation, who is going to talk about complex word identification for the Italian language, a dictionary-based approach.
Yes.
The floor is all yours.
In a second. Yeah.
Hello, everyone, and thanks to survive. Today, okay, I know that Italian normally is not considered a low resource language, but I think that for some specific task, we don't have resources. And so today I want to talk with you about one specific task that is complex word identification. So we will have a little overview about this specific task and also how it is treated in Italian or not treated before this moment. And after that, I want to explain you how I implemented this system. So the dataset creation, the feature selection that is very important for this task, and also the training of our models. And I think the most interesting part of this presentation is the evaluation part, because we made two different evaluations. One with it's an internal one, and another is with an external resource that we create in this research, in this investigation. Complex word identification is a task of NLP that aims at identifying the words that are perceived like difficult for certain readers. So how can you understand by complex word? We refer to something very relative. So we have to ask to who is complex this word. And also we have to consider some specific parameters sometimes that are very related to the speakers. This task is very important, and this is demonstrated because now there are a lot of different shared tasks. Someone considered this like a standalone task because it's very important also for the development of systems that can facilitate language acquisition or for the creation of reading tools. Indeed, the complexity is very important also for readability, like we saw this morning. And also it is the first step of the pipeline of lexical simplification. And so it's very important because the first things to simplify something is to recognize that something is difficult and have to be simplified. When I'm a little bit off topic in this section because when I talk about a word, I mean only a single lexical item. So I will not rate about multi-word expression because all the situation is a little bit more complex in this case. And for me, it's very important that you remember this information because complex word identification can trade in two different ways. The first one is the more simple one, and is a binary classification that consists in identifying and label a word as simple or complex. So it's totally binary. The second approach, that is the one that now is more used, is called the lexical complexity prediction, and is a classification that is continuous. So a word receives a value that goes behind the 0 and 1, and it's a continuous value, so it's not binary. In the Italian language, to the best of our knowledge, this task is never being studied or systematized. Indeed, it's very common, I don't know, in English, in language like English, or in Japanese and Spanish, but other languages is not considered too much. And I think this is by two main reasons. On one side, I told you before that we don't have specific resources for this task. That normally means that we need data set with human evaluation because complexity prediction is very relative. And so we need a lot of annotators and for this type of task. And another, I think that a lot of very good linguists that also work in lexical simplification or in general in textual simplification consider our basic vocabulary of usage like enough to recognize if a word is simple or not. What is the meaning? That during the simplification, all the words that were included in this very important resource are considered like simple. All the ones that are not included are automatically complex. But the situation is a little bit more complex than this, because if you think about the word abolizione, that is like abolition, it is not included in the resource, but we have the verb, I don't know how it is in English, abolire, yeah, abolish, and so abolire is considered like simple, but abolizione like totally complex. This is strange because we know that also with morphology, people can decode the information sometimes. So we try to build a system with machine learning. And so we had to create, like first things, a data set. Unfortunately, the approach that we used in this investigation is dictionary based. Why unfortunately? Because for sure we know that also the complexity of a word is connected to the context of the word. So using a dictionary approach is a little bit limiting, but we think that we have to open this topic, and also this system help us to create the first resource that can be really used for lexical simplification pipeline in Italian. So we will see that we created the data set, but also the choice of the words considered like simple or complex is very, very difficult, because one of the main challenges is about what is complex in a language. So how can we define the complexity? The second step is the identification of some linguistic features that correlate with the perception of complexity of the speaker. And in this case, we consider a normal speaker, so not a speaker with some disabilities that have another treatment, and we need to consider very specific parameters. And after that, we try to training very different, not very configuration of parameter in the same system. For the dataset creation, so we decided to build a list of words, but we didn't know to influence with our bias the choice. And also we don't want to use the frequency like the unique parameter, because in all the previous studies, the frequency was the only one, but also in literature, there are a lot of literature that say one parameter is not enough to define anything. And so we were trying to think, how can we, what criteria we can choose to select some words in the more objective way we can. And so the things that we thought was about the common European framework of language. And so we decided to consider like simple word, the first three levels between A1, B1, because are the first words that everyone that started to study Italian learned in the first stage. And so luckily we have several resources in Italian strictly related to language acquisition. So there is the Merlin corpus that is like a collection of text produced by foreign learners. And we selected, it's very interesting because this corpus is produced by learners and there are a lot of metadata inside. And we selected the metadata connected to vocabulary range that has the specific label connected to the level of the framework of common language. There is Kelly, that is a kind of, all these resources are very, are built with some pedagogical workers that study all these things. And so it's very interesting also because also teacher help in the creation of these resources. So there are some resources that are built from the University for Range of Perugia. That is very important one. And we selected A1, B1, A1, A2, B1, sorry, B2 no, I made wrong. And the only resource that is not connected with the language acquisition is the last one, that is Varles, that I really want that this resource is bigger because it's very beautiful. It contains only 626 Italian nouns, but it's very interesting because there are a lot of lexical and sublexical variables connected to this, because they build this with a lot of psycholinguistical experiments. So we have some metrics that are very important for our system. For the complex word, the discourse was a little bit more complex because we don't have too much resources like Italian L2 in this level, and also because all the resources that we have are based on pragmatics of the language. So it's a little bit more difficult to find some resources only connected to the lexicon. And so we found this dictionary that was built in 2016. And it consists, it's very interesting resources because it consists of very rare words, but also words that are technical words or words that normally you can use in a different register. And so we decided to take part of this complex word to include in our list to implement our system. So our final data set consists about of 30,000 forms that are categorized as simple or complex. And after that, we started to think which kind of features we can search, which kind of parameter can help us to define the complexity. And okay, the literature presents a lot of different features very connected to complexity. And we have to choose the one that we can for sure implement. And also the only part in which we work more was about morphological features. Because, okay, some features are very common and are surface features, but in which the correlation with the perception of complexity is very strong. Because we know, for example, the decoding time is very important to understand if a word is very is known or not about the reader. So we consider some surface features like word length, syllable count, vowel count. We consider the frequency, but about two different corpora, because we thought that frequency is too much connected to the corpus that you use. And so we try to balance a little bit this parameter, if the word is stop word or not, and so see if it's very common or not. The number of senses was extracted with the Ital WordNet. That is not so full resource, so there are some limitations. But for the morphological features, we implemented a convolutional neural network to segment automatically. And after that, we count the number of morphemes, the relation between the number of morphemes and the length of the word, and also the frequency of the lexical morpheme. So we used our model on the two frequency corpora, and we made the extraction of the frequency of the root. The evaluation of we try to implement a random forest algorithm. Okay, here I present to you only the random forest, but we tried very different classifier. And we decide to consider different model configuration. So we want to know, okay, frequency is enough to understand if a word is complex or not. Feature-based model that include all our model. We try to compare also with the only embedding models and with the total model that for sure is the one that works better. It's not a spoiler, but. So we trained our model, and for me, it's very interesting to see that frequency for sure has a strong impact in the prediction of complexity. So the important part is only to the problem is that when a word is zero frequency, the probability of that is a complex word is 1. So it's too much. So we have to balance this parameter with other one. I think it's interesting that the feature-based model is very similar to the embedding one, but we can understand which features impact on the complexity. So we made some correlation to understand which linguistic parameter correlates more with the complexity perception. And after that, the total model for sure is the one that works better. This is the internal evaluation. For the external one, I was the pleasure to work with a very big group because we built all together the multi-LS dataset. That is, we proposed a shared task about lexical simplification multilingual, and I built the Italian dataset starting from the model of before. The Italian part consists of 600 sentences with 6 target words. In reality, are 200 contexts, and so we have 3 words in each context. And the words were annotated with complexity and with, substitution is for the other side of lexical simplification. In this context, we only consider to the lexical prediction. And so we have a minimum of 10 annotators, and we aggregate the complexity. And after that, the annotator have this Likert scale to label that go between 1 and 5. 1 is very easy, 5 very difficult. We correlate the percentage of the belonging to our classifier is binary 1, but we have we are lucky and we have also the probability of belonging to a word of one or the other class. And so we use the probability of classification of our predictive model with the aggregate human judgment. And so we saw that for the lexical complexity prediction, these are the evaluation metrics. And also our model was kind of good, but to understand if it's very good or not, we tried the comparison between the inter-annotator agreement and the agreement in our model. What is the meaning? Our model was like was the 11 annotators. So we compared the inter-annotator without our model and the inter-annotator with our model to understand how they are similar. And luckily, the correlation is, we use the Spearman correlation because we were talking about ordinal values and very ranging one. So our system and the inter-annotator agreement fall within the same range. So we have for sure some problems because the value is not so high. So we need to improve for sure all these things because I told you before, this task is a very subjective task. So we need more annotator also to have a higher inter-annotator agreement. For sure, the main limitation of this work is that is context agnostic, but this research that I present to you is the first one that we hope to create a bigger one, so increase the sample size, the type of text that are inside, and also the number of annotators in which that we can have a more clear situation. And for sure, it will be very interesting also introduce the multi-word expression, but I think it's another very big word. But I'm happy because we open a topic in Italy that was never tried before. And I hope that could be useful also in here because I think it's a very interesting topic and also with some social impact. So it's always something good. Thank you very much.
Thank you to our presenter. The floor is all yours.
I hope not too fast.
No.
Okay. No. Because sometimes I have this problem.
Okay. 6 minutes to discussion.
Thank you for your nice presentation. I have 2 questions. One has to do with the morphemes. You said that you consider the frequency only of the roots.
Yeah.
Why did you neglect the affixes?
No, it was only for because I think we know that Also the affixes are very important. But sometimes affixes are for sure more frequent than roots. And so for this is like, okay, we are more interested to understand if they know the main meaning. And after that, you can compose it with the knowledge that you have. Yeah, it could be very interesting also add the frequency of the other morphemes. But we consider the Lexan one because it's like the main information builder.
Okay, I understand. Well, I asked this because people say or used to say that negative prefixes are sometimes harder to decode by a speaker or a listener. And maybe when you have a word derived with in a series, so with several affixes, their combination may become more difficult to process.
I agree. And for this, I'm sorry that the measure that some parameters that we have are only quantified. How can I say this kind of information is reassumed in the number of morphemes and stuff. So it could be very interesting also to understand if there is a difference between affix or suffix in so probably I will work also on this, I hope. Thanks.
And the second thing I was thinking of is, well, as long as this is a subjective test, let's say, or what process, have you considered sampling the annotators so that they have the same level of education? I don't know, they are frequent readers or not?
Okay, we consider this. Okay, you have to consider that we built the dataset we don't have any specific information. So I have all the metadata. I collect all the metadata, but I don't have very specific information, statistical information about the different degree. And so I don't know how they chose the complexity or not, because for this task, we were interested only to a very general Italian. So we were happy that it was very, we have very different types of annotator, but it could be interesting to have some specific information. But I think that we have to have a more big annotator sample. Yeah, because now we have only 10, 11 annotators for each sentence. So we need more, I think, and also more sentences and words.
Thank you and good luck.
Thanks for the question.
So I've got 2 questions, and I know that I need to have that this time. So it's, I'm actually going to review how incompetent I am, but you use the term stop word. What do you mean by that?
Stop word normally are included in some very specific toolkit, and with stop word are the very common one, like preposition, or very, very, very common, like casa. It depends from the model that you use. For example, I calculate this with spacey. So there are the Italian stop word that spacey consider inside, but normally they are like articles, participles, so very frequent words. That is like, okay, for sure people knows this one. And also this is a very, in NLP analysis, sometimes stop words are removing like the first things because they don't add too much information. It depends from the task that you want to consider for sure.
I admitted that
it's...
No. Okay. And the second question, are you ever going to consider differences between inflectional and derivational morphemes?
No, we didn't go...
No, in the future. Now I understood.
Yeah, I like the idea.
Okay, so it would go into complexity measurement, and then you would have to deal with affixes.
Yeah.
Okay, I'm sorry.
Thank you very much.
If there are no other questions or comments, let us give a round of applause. And invite to the floor Ivana Brach, and I apologize for any mispronunciation. who is going to present to us their work on verbal multi-word expressions in the Croatian verb lexicon. The floor is all yours.
Thank you. Thank you. So in this talk, we will present some solutions for the treatment of verbal multi-word expressions in the Croatian verb lexicon Verbion. It is a work in progress and we are still developing our database. So all your suggestions are more than welcome. As you will see, we don't know how to deal with some things. This project began this year, and one of the objectives is to create a database that will contain description of the 500 most frequent verbs in Croatian. More precisely, verb sense and valency frame is based on examples from the corpora. And each verb sense, example, and idiom will be translated into English. And some colleagues showed their interest to translate them into Spanish and French also. And they were a suggestion to translate into Polish, since many students in Poland study Croatian. I mean, not many, but for Croatia, many students. The list was extracted from several corpora containing more than 100 million tokens. And we also compared this list with the list compiled at the Institute for the Croatian Language. We have an Excel file that contains 24,000 verbs, but some of them are obsolete and I never heard of them. So we compared this list in Excel file to the Croatian School Dictionary and the Croatian Language Portal, which is largest freely available dictionary. And still some verbs were not attested, nor in the corpora, nor in the dictionaries. And then we Googled them, and some of them were attested, and they usually belong to some special field domains. They are verbs as terms. So we wanted that one of our results would be also a publicly available list of Croatian verbs. We believe that is going to be more than 20,000 verbs. So it won't be anymore only in our Excel files in our computers, then it will be available. We took 1,000 verbs from each corpora and divided them into semantic classes. And then we had to decide whether we should select 500 verbs based on a semantic class, for example, 7 semantic classes, and then describe them, or 500 verbs based on frequency. And then we decided based on frequency, as we promised, 500 the most frequent verbs. Verbs are described at several levels. Here are some general information, verb, English equivalent, and morphological aspect. And then we have morphological block, which is not directly related to valency, but we decided to include it since we believe that it could be useful both for non-native speakers and also native speakers, because we included some tenses that are not so frequently used, such as aorist and imperfect. Each sense has definition in English. Then we determine semantic class based on Levin's and Verbnet's classification. And we also added the Verbnet classification. And you can see an empty field, semantic class syntactic. It is awaiting for our classification. By the end of the project, after we process all verbs, we plan to propose our classification based on Croatian data. Each sense has one or few valency frames, and each valency frame has one or more examples. This is an example from the corpus and its translation into English. And we have an analysis. At the syntactic level, we use syntactic phrase types. We believe that is the most convenient way because people from different linguistic backgrounds are familiar with syntactic phrase types. Since Croatian has 7 morphologically realized cases, we also determine which case and prepositions are used. For semantic roles, we mainly adopted Verbnet's semantic roles with a few modifications, and we also provided possibility to assign 2 semantic roles. Frame elements from FrameNet and also lexical units, which are sometimes mandatory, which I'm going to explain soon. In this presentation, we try to answer these research questions. How should reflexive verbs, verbs with the reflexive marker se, be treated? Should they be considered as separate lemmas, sublemmas of intransitive counterparts, or one of verb senses? Second, what syntactic label and semantic role should be assigned to a predicative noun in light verb constructions? And should verbal idioms be included, and if so, at which level of description? Regarding reflexive verbs, we looked at a few Croatian general online dictionaries, how they treated them. Croatian Language Portal, which is the largest freely available dictionary, Croatian School Dictionary, and Croatian Web Dictionary, which is corpus-based. and also valency lexicons such as Krovalex, which is based on the Czech Valex 1.0, and it has around 1,000 verbs. E-Glava, which has only 57 psych verbs, and it is based on the German E-Valbu. And we looked at the Czech Valex as a role model. Regarding reflexive verbs and their classification, in Croatian there are several classifications, and this is the most accepted one. So we have inherently reflexive verbs or reflexiva tantum. They cannot appear without the reflexive marker se, for example, smijati se, natjecati se. Then so-called proper or true reflexive verbs, they are transitive verbs whose object can be replaced by the reflexive pronoun sebe. For example, češljati koga, komb someone, I češljati sebe, komb oneself. But they're a bit problematic, we will see in the next slide. Then reciprocal reflexive verbs such as kiss each other and deride, they have transitive and reflexive counterparts, but the reflexive marker se cannot be replaced with sebe. For example, igrati, I igrati se. We cannot say igrati sebe. There are many discussions what is se in Croatian. Some authors view it as a pronoun, some consider it as a particle, and some think that it's a particle with reflexiva tantum and derived reflexives, while a pronoun with proper reflexives. But in the recent studies, it has been shown that they are not interchangeable. For example, we can say Marija se počešljala, Marija comb her hair, but we cannot say Marija je počešljala sebe without context. It sounds unnatural to native speakers. But we can say Marija je prvo počešljala sebe, pa dijete. Marija first combed her hair, then the child's. So we need semantic and pragmatic reasons to use sebe instead of se. And se is an integrated part of reflexive verbs, so we decided to treat reflexive verbs as separate lemmas. In dictionaries, the situation is simple with reflexiva tantum. It's headword, of course, while situation with so-called proper reflexives is a bit complicated, and it's not coherent in one dictionary, let alone across dictionaries. For example, here we have bath. The first meaning is to wash somebody in a bathtub or container filled with water, and it can be transitive and reflexive. So they put se in parentheses next to the headword. But it has also the second meaning, be in water or swim, and it can be only reflexive, so it's listed as sublemma with reflexive label in parentheses. Buditi, wake. The first meaning is to interrupt someone's sleep, bringing them to a wakeful state, and it can be only transitive. While buditi se, meaning to get out of bed after sleeping, they believe it can be only reflexive, so it is sublemma. Regarding reciprocal verbs, they are treated as sublemmas. I think that I skipped. Yeah, here we have this solution when se is listed next to the object pronouns. For example, wash, someone, something, se, and then we have definition of transitive verb to remove dirt by rinsing in a liquid. I said about reciprocal, so also here ljubiti, kiss. It is listed next to the object pronouns kiss, someone, something, se, and we don't know if it's reciprocal or it is a proper verb, so there is no any further description. In Krovalex, reflexiva tantum, reciprocal, and derived reflexives are treated as lemmas, while here the proper reflexive, you can see, if you can see this fourth meaning, it's wash, and it has definition to remove dirt from oneself with water and soap. So there is no any indication relating to reflexivity, and instead of the definition. From the definition, we know that it's a reflexive verb, and also from the example, the swimmer washed himself with a brush. In E-Glava, only reflexiva tantum are lemmas, while other reflexives are senses. For example, the second sense is to take offense and reflexive label. And the fourth meaning is to insult each other. So it is reciprocal with reflexive label. In the Czech Valex, all reflexive verbs have the attribute reflex verb, and the reflexiva tantum has the value tantum, while other reflexives have the value derived, and they are further classified into 7 categories based on syntactic operations. In our database, since it is a dynamic database that offers flexibility to record as many verbs as we want, we decided to treat them as separate lemmas and to introduce the labels tantum, derived, reciprocal, same as in Valex. So in this way, users can easily filter the categories that they are interested in, and also it opens the possibility to improve the description in the future, for example, to include passive and middle voice, and also syntactic operations as in the Czech Valex. It looks like this. Here we have buditi, wake. Its definitions are to interrupt someone's sleep, to arouse feelings or states from the past, to arouse a particular state or mood in someone. And the reflexive verb, the separate entry, buditise, reflexivity box is checked, as you can see, and the definitions are to stop sleeping, to bring oneself into wakeful state, and to come into a state of liveliness, to move or activate oneself after a period of passivity or inactivity. And the analysis, boatisse, is reflexiva tantum, to be afraid. We have an example, I'm afraid of heights. I is an NP in the nominative case with the role of the experiencer. Boimse is ve with the value ref tantum, and the heights NP in the genitive case stimulus. Derived reflexives, for example, wake up. If the child wakes up because of teething, we have the child, NP in the nominative case, and here we have two roles, experiencer and involuntary agent. Then buditisse is derived reflexive because of teething causer. Reciprocal, the couple was kissing passionately, the couple NP in the nominative case with the role of the agent. Se ljubio has the label ref recip. And also she is passionately kissing with her new boyfriend. Here we have with her new boyfriend, it is a PP, and the semantic role is a co-agent. Regarding the light verb constructions, the situation for us is more complex because we don't know how can we be sure if a verb is semantically full and or semantically bleached. Also, is a noun an object or part of the predicate? Does a verb assign the semantic role itself predicative noun or both of them? So we look also at valency lexicons. In Cro-Valex, we have a verb, it's bring. And then in the definition field, we have a simple verb equivalent, it's to decide. Frame is empty, and the example is light verb construction, to bring a decision, meaning to make a decision. But in the same manner, verbal idioms are also treated. Bring, to give to someone who has not made any effort. And in the example we have to bring on a plate in Croatian means to hand something to someone on a silver platter. In the Valex, first meaning is semantically full verb. We have frame, actor, obligatory in the nominative case, patient, obligatory in the accusative case, and beneficiary, non-obligatory in the dative case. And the second meaning is complex predicates, and it also has frame, actor, obligatory in the nominative case, and a compound phrase, which is obligatory in the accusative. And under light verb constructions, or nouns that can be used in this position are listed. And you can click on a noun and it directs you to the valency frame of a noun. So we decided to do like this. We have here highly schematic verb, meaning to conduct, carry out. It is only light verb, and it has three definitions. First is light verb that with the verbal noun means to perform or carry out some activity. And the example is our engineers conducted tests of the seabed. Here we have the engineers, NP in the nominative case with the role of the agent. And light verb we labeled as LV, light verb, so we can be easily filtered in the future. Then we have the testing, it's NP in the accusative, and we didn't assign semantic role, but lexical units are obligatory, so you can conduct analysis, cleaning, diagnostic, distribution, delivery, and so on. And then the seabed, here is NP in the genitive case with the role of the team, which we are not sure about. The second meaning is light verb that with a deverbal noun means to cause a certain state or feeling. For example, she claimed that her parents had exerted tremendous pressure on her. Here, as a predicative now, we can have pressure, hunt, chase in Croatian. And the last meaning, light verb that with deverbal noun means to hold a certain position. And the example is in the early 70s, he also held the position of club president. In Croatian, you can hold duty or service. What we are not sure about is should we assign semantic role to the NP in the accusative? Since a light verb is incapable of assigning one, so we decided to leave it empty, but maybe due to argument sharing, it could be also team. And also we had problem with this seabed, this NP in the genitive case. If it is a complement of a noun, if it is, then it would be treated ispitivanja podmorja, testing of the seabed, as one constituent. It would be NP in the accusative. But also due to argument sharing, maybe predicative noun transfers its argument structure to light verb, and it could be assigned the role of the team. And also if we substitute a light verb construction, for example, the engineers conducted testing of the seabed with semantically full verb, the engineers tested the seabed, then this NP in the genitive case comes into the position of the direct object in the accusative, and it has the role of the team. I would be happy if you give me a solution, and that's it. Regarding verbal idioms, sometimes in dictionaries, verbal idioms are not listed. Nouns and adjectives are, but verbal not. In some dictionaries, there is a field phraseology. We have an idiom, for example, sell wisdom in Croatian, and definition to give unsolicited advice. And in Croatian Web Dictionary, we have also definition to give it your all, meaning to do everything within one's power, and example from the corpora. And the same manner is also in e-glava, where we have a field, idioms, and collocation, and also have an idiom, this definition, and an example from the corpora. In Czech Valex, also verbal idioms have their valency frames. For example, hoća zahlavu, it's actor obligatory in nominative case, patient obligatory in the accusative case, and dependent phraseme obligatory. And this place for cases, we have zahlavu, those fixed elements. In Valex, at the moment, verbion at the moment is like this. We have idiom prati ruke, English idiom wash one's hands of something, definition in Croatian and English, disclaim responsibility or involvement in a matter, and an example, the international community is washing its hands of the Dayton Agreement today. We don't have, at the moment, further analysis, but we would like maybe something like this. So the international community, NP in the nominative case with the role of the agent, and pere ruke is one constituent, labeled maybe as verbal idiom with, of the Dayton Agreement, PP, odd plus, from plus genitive, with the role of the team. And as a conclusion, we still believe that our decision to treat reflexive verbs as separate lemmas is a good one, since it makes easier further analysis of reflexive verbs and introduction of syntactic operation. Also, by labeling light verbs as LV, we believe that it's easier to list all verbs that are used as light verbs. And also by introducing lexical units, we believe that we improve the lexicon's usefulness. Regarding verbal idioms, we are waiting for a happier future, maybe for more collaborates who could do that, to be only dedicated to verbal idioms. But at the moment, we build a translation into English will be the greatest advantage, since there are no publicly, openly available resources that have translation into English, let alone any other language in Croatia. So that's it. Thank you.
Please hold yours for questions and comments.
Too late for questions.
And too hot.
Too hot, that's true.
Very nice presentation. Thank you. Well, because I don't understand Croatian and you're quite fast. Could you explain again, do you have thematic cases assigned to components of the multi-word expressions or to the words that they combine with?
Sorry?
So go again, please, to one of your last slides where you presented idioms.
Verbal idioms.
Yeah.
Yes, let's say verbal idioms.
Okay, this one.
This one, yes. So those elements that are assigned semantic role, you call it, yeah, are parts of the idiom or not? No. So you have actually valence frame which is enriched with semantic information.
Yeah.
Okay, very nice.
Pere ruke, wash hands, it's fixed, and everything else can be changed. But agent has to be in the nominative case, and this team has to be odd plus genitive case.
Yeah, very nice. Quite a lot of information. Do you also have a morphology of the components? So which, for instance, well, I understand that that's all that's available for idioms. It's interesting also to find out if some of the components can inflect in idioms. Do you have this?
All these that the semantic role is assigned, they can. I mean, they have this case.
No, not the external. I mean the components of the idiom. Those.
Yeah, it is accusative in plural.
Yeah, no, so can any of those components, well, the verb probably inflects to agree with the subject, of course. What about ruke?
No, it's ruke, accusative.
Yeah, do you have this information encoded in your dictionary? Because you may have longer idioms. Sometimes they are prepositional phrases. There are some adjectives involved. So do you have information if they can inflect or if they can be modified by...
At the moment, we don't have this table. It is wishful thinking. But I think that it's a good idea. Maybe this here within the field of morphology, we could add, it can be with verb, it can be everything, but it has to be accusative plural. We can add that maybe, that information.
But can you, what is that, Ruke? Is it a noun?
Yeah, hence.
Okay. So is the plural?
Plural.
Can it be used in the singular, for instance? That's important information. Will you add it to the dictionary? Or if you can insert words between the verb and the noun. So can they be discontinuous in text?
I think that he can. He is washing his hands of something.
Okay, so
it could be, yeah.
Do you envisage adding such information as well, or if their word order can be is flexible or not? So if someone could use the noun before the verb, if the language allows for word order variations, of course.
It allows, but it would sound strange. Ruke, pere. Yeah, it would sound strange. Yeah. Verbal idioms are usually, not so important for valency description, but we wanted to include them because we have non-native speakers in mind. We plan in the future to make this database as much useful to non-native speakers to practice Croatian. So verbal idioms, of course, are important, but we don't have people.
Yeah, and you mentioned several resources that inspired you. I suggest you check for others that are dedicated to multi-word expressions. For Czech, you have Lemur, a rich resource, and also rich in information that is added to idioms, to all multi-word expressions they contain. I will give you a reference.
Thank you.
Yeah.
Yeah. Thank you.
No further questions, or at least I don't see many raised hands. We are all gasping for air, obviously.
Water.
So let us give a round of applause to our presenters. Thank you. Thank you everybody for your active participation. Enjoy the walk, and do not forget that you need to be at 8 o'clock. I forgot where. No. Tomorrow is here. They have the announcement that was made earlier. Dobro. Good evening to everyone.